Sit back, relax, and let's listen to this audio and learn about the people who were smarter than the famous Einstein. When most people hear the word genius, one name immediately pops into their heads like a neon sign: Albert Einstein. He's the guy with the wild hair, the mischievous smile, and the brain that supposedly bent the universe to his will. He's practically the poster child for intelligence itself. If you want to tell someone they're smart, you compare them to Einstein. If you want to sell Halloween costumes or posters that scream science, you slap on a mustache and a wig and boom, instant Einstein. Pop culture has crowned him the king of brains, the gold standard of cleverness, the face of genius that will never fade from history books or coffee mugs. But here's the big question: is that crown really deserved? Or is smart a lot more complicated than relativity, hair that looks like it lost a fight with static electricity, and an IQ score that may or may not even be accurate? To answer that, we have to think about what we even mean when we call someone smart. Because if you dig into it, Einstein wasn't the only scientist who changed the world. He wasn't even the only scientist of his era who was doing groundbreaking work. But the story of his genius is one of those cultural shortcuts. He's the symbol, the shorthand, the one name everyone knows. When you ask someone to name the smartest person in history, most people don't say Newton, Curie, Turing, or Noether. They say Einstein because Einstein's legend has escaped the laboratory and landed in everyday language. His name is less a person and more a synonym for brainiac. That's powerful branding. But it's not necessarily the full truth. Einstein became iconic largely because of relativity. The theory of special relativity in 1905, followed by general relativity in 1915. These ideas transformed our understanding of space, time, gravity, and the universe itself. Suddenly, concepts we thought were solid, like time being universal or gravity just being a pull, turned out to be flexible, relative, and dynamic. Relativity didn't just tweak physics, it rewrote it. Add in the fact that relativity had flashy, mind-bending consequences like time dilation, black holes, and bending starlight, and you've got science that sounds like science fiction, but turned out to be real. That makes for great headlines, dramatic experiments, and a permanent place in the public imagination. Einstein's genius wasn't just in the math, it was in creating a vision of the universe that was so strange and yet so correct that people couldn't ignore it. But here's the catch. Einstein wasn't the only one reshaping science. In fact, if you compare contributions, he sometimes looks like just one genius among many. Isaac Newton basically invented calculus in his spare time and laid down the laws of motion and gravity that powered centuries of physics. Marie Curie discovered radioactivity, won 2 Nobel Prizes in different sciences, and basically melted her way into history. Emmy Noether created theorems so fundamental to physics that Einstein himself admitted her brain outshone his. And then there are modern thinkers like Alan Turing, who cracked codes and fathered computer science, or Srinivasa Ramanujan, who with barely any formal training wrote down mathematical insights so far ahead of his time that experts are still catching up. So why doesn't culture say, "You're a real Noether," or "You're the Ramanujan of this class," instead of "You're an Einstein"? Part of the answer is that smartness isn't just about raw brain power. It's also about timing, communication, and image. Einstein hit the world stage during an era when mass media was exploding. His face was on newspapers, his lectures were international events, and his personality charmed the public. He was quirky, quotable, and photogenic in his own messy way. He made complicated science sound mystical but approachable, and he became a symbol not just of intelligence, but of curiosity itself. In other words, he was a PR dream. Other scientists may have been as smart or smarter, but Einstein was the one who became a celebrity. That's why the big question matters. When we say smarter than Einstein, we're not just comparing equations. We're comparing legacies, influence, and myths. Intelligence isn't a single number like an IQ score, no matter how many times magazines love to print charts of world's smartest people. It's multidimensional. Some scientists are brilliant because they invent entirely new fields. Others because they solve problems nobody else could crack. Others because they translate complexity into simplicity so the world can understand. Einstein was great at some of these things, but not all. His mathematical skills, for instance, weren't always the sharpest. He often relied on mathematicians to help formalize his ideas. Compare that to Ramanujan or Noether, whose raw math left colleagues in awe, and suddenly Einstein doesn't look like the undisputed king of brainpower. What makes this so fascinating is that genius isn't one size fits all. It's not a contest where you measure skull sizes and hand out trophies. It's more like a messy toolbox where different people bring different kinds of brilliance. Newton brought the precision wrench of calculus. Curie brought the radioactive hammer of experimentation. Tesla brought the spark plug of imagination. Einstein brought the wild blueprint of relativity. Each one shifted the world in their own way, and comparing them is like asking if a rocket is smarter than a smartphone. Both are incredible, both are transformative, and both redefine what humans can do, but in different arenas. So why does Einstein keep winning the genius popularity contest? Because his discoveries hit the sweet spot between being incomprehensibly abstract and visually spectacular. Time dilation sounds like science fiction, but then you see astronauts actually aging differently in orbit. Light bending around the sun sounds magical, until telescopes confirm it during eclipses. Black holes were once wild speculation, now they're photographed. Einstein's ideas didn't just sit on chalkboards, they created phenomena that captured imaginations. Pair that with his eccentric look, his pacifist ideals, and his witty one-liners, and you've got a genius who is as much a cultural character as a scientist. But here's the teaser for the rest of this journey. If Einstein is the symbol, there are plenty of scientists who are just as brilliant, sometimes even more so in their fields. We're talking about pioneers who redefined biology, invented new mathematics, envisioned technologies centuries ahead of their time, and fought through obstacles that Einstein never had to face. Some of them were overshadowed by sexism, racism, or lack of media attention. Some of them worked in obscurity, their brilliance only recognized decades or centuries later. Some of them, like Noether, were so revolutionary that even Einstein admitted they surpassed him. And that's the heart of the big question. Smarter than Einstein isn't about dunking on the man who gave us relativity and inspired generations. It's about reminding ourselves that genius wears many faces. It's about exploring the forgotten, the overlooked, and the underrated brains who changed the world in ways just as profound. Einstein's crown might shine the brightest, but it's not the only one. In the chapters to come, we'll meet the other geniuses, the other Einsteins, scientists who proved that brilliance comes in all forms, and that smartness is far more complicated than a single mustachioed poster boy for relativity. So buckle up, because Einstein may have been the genius everyone remembers, but he was far from the only one who deserved the title. The big question isn't whether he was smart, it's whether we've been too narrow in who we call genius at all. And once you see the full lineup of brilliant minds, you'll realize the truth. Einstein was great, but he wasn't alone. When people throw around the word genius, they usually imagine it as some kind of scoreboard, like there's a giant invisible chalkboard in the sky where IQ scores are scribbled down, and whoever has the biggest number automatically wins the prize for smartest human ever. Einstein supposedly had an IQ of 160, which sounds impressive, so people hear that and think, okay, he's the champion. But the problem with measuring smartness is that it's not a simple number game. Intelligence isn't like counting how many jelly beans are in a jar. It's more like arguing over pizza toppings. Some people swear by pepperoni. Some people will fight to the death for pineapple. Others think plain cheese is the ultimate. And the truth is, it depends what you're hungry for. Genius works the same way. Are we measuring IQ, creativity, the scale of impact, or the ability to explain complicated ideas in a way people can actually understand? Depending on which topping you pick, you get a different, smartest person alive. Let's start with IQ, because it's the most famous way people think about intelligence. IQ, or intelligence quotient, is supposed to be a standardized score that compares your mental abilities to the average person. It's been around for over a century, used in schools, the military, and psychology. It tests things like problem solving, pattern recognition, and memory. A score of 100 is average. Einstein's rumored score of 160 puts him in the genius category. But here's the kicker. Einstein never actually took a formal IQ test. That number is just an estimate, and estimates are basically fancy guesses dressed up in lab coats. Even if he did take a test, would it really measure the kind of genius that let him dream up relativity? Probably not. IQ tests are good at measuring certain skills under pressure, but they don't always capture imagination, vision, or the willingness to challenge conventional wisdom. That's where creativity comes in. Creativity is the ability to see connections others miss, to link ideas in new ways, to imagine possibilities that don't exist yet. Einstein himself once said that imagination was more important than knowledge. He believed that knowledge tells you what already is, but imagination shows you what could be. Think about special relativity. He didn't start with equations. He started with a thought experiment. What if you could ride on a beam of light? What would the world look like? That's not an IQ puzzle. That's a creative leap. Plenty of people could have memorized formulas, but Einstein had the audacity to ask bizarre questions and then chase them until they made sense. If you measure genius by creativity, suddenly artists, inventors, and visionaries stand shoulder to shoulder with physicists. Nikola Tesla, sketching wireless energy towers in his notebooks, looks like a creative genius even if he wasn't solving math puzzles at lightning speed. Leonardo da Vinci, dissecting corpses while dreaming up helicopters, blows the creativity scale through the roof. By that standard, Einstein's genius is still huge, but he's not alone at the top. And then there's impact, maybe the hardest topping to rank, but arguably the most important. Impact asks, how much did this person's ideas change the world? If genius is a tree, impact is how far the branches spread. Newton's theories of motion didn't just impress other scientists, they powered the Industrial Revolution, space exploration, and every rocket launch to date. Marie Curie's discoveries in radioactivity transformed medicine and physics, saving lives while also introducing brand new dangers. Alan Turing's work on code-breaking arguably shortened World War II and helped invent computers, which you're using right now to watch videos and order pizza. Ramanujan's math still influences modern number theory, cryptography, and even string theory. When you weigh impact, you're not asking who had the fanciest ideas, you're asking whose ideas reshape civilization. By that measure, Einstein is a heavy hitter, but not necessarily the champion. His theories of relativity rewrote physics and made GPS possible, sure, but are they more impactful on everyday life than the invention of electricity, antibiotics, or computers? It depends on what you value more, the cosmic view or the daily grind. And that's why comparing geniuses is like arguing about pizza toppings. IQ gives you one flavor. Creativity gives you another. Impact gives you yet another. There's no universal winner, just different tastes. It also explains why some geniuses go unrecognized for so long. Emmy Noether's abstract mathematics underpin modern physics, but for decades, hardly anyone outside academic circles even knew her name. Her genius wasn't flashy or easy to explain to the public, so it didn't stick in popular culture the way Einstein's did. Impact takes time to show itself. Sometimes the smartest people don't look like geniuses until centuries later, when the world finally catches up. Another layer to this messy measurement problem is communication. Some scientists are brilliant at ideas, but terrible at explaining them. Others shine because they can take the most complex theories and make them digestible for the rest of us. Richard Feynman, for example, wasn't just a Nobel Prize physicist, he was a world-class explainer. His genius wasn't just in solving equations, but in teaching them with clarity and humor. That kind of skill multiplies impact, because ideas don't change the world if nobody understands them. Einstein himself had this gift too. He was quotable, approachable, and he framed his mind-bending concepts in simple phrases like, "God does not play dice." You could argue that part of what made him the symbol of genius wasn't just his science, but his ability to communicate it. A silent genius who never shares ideas might rank low on the impact scale, even if their brain was operating at warp speed. Cultural context matters too. Sometimes geniuses are measured not just by what they know, but by what they overcome. Marie Curie had to break through enormous barriers as a woman in science, at a time when women weren't even allowed in many universities. Her achievements aren't just about radioactive elements. They're about persistence, resilience, and vision in the face of systemic obstacles. Srinivasa Ramanujan worked out groundbreaking math with almost no formal training, scribbling theorems that would later stun Cambridge professors. If we measure genius by raw brainpower alone, Einstein's in the club. But if we measure by perseverance, creativity under pressure, or ability to thrive without resources, other names rocket to the top. Even within IQ itself, the story gets messy. High IQ doesn't always translate to genius. Plenty of people score brilliantly on tests, but never produce world-changing ideas. Genius seems to require a cocktail: intelligence, creativity, persistence, and sometimes just being in the right place at the right time. Einstein might not have been the most mathematically gifted of his generation, but he combined curiosity, imagination, and timing in a way that clicked with the world. That combination made him unforgettable. But it also means measuring genius isn't as simple as asking who had the highest IQ. It's about asking whose mind bent the world in ways that will never be the same. So here's the irony. The more we try to measure genius, the more it slips through our fingers. We love rankings and lists, top 10 smartest people of all time. But intelligence refuses to be boxed in. One genius might shine in equations, another in experiments, another in inventions, another in communication. Einstein gets the crown in pop culture because his genius had the perfect recipe for public memory. Radical ideas, visible impact, and a quirky personality that made him stand out. But if you swap the metric, if you measure by creativity or survival against odds or raw mathematical power, other geniuses start looking just as shiny, maybe shinier. That's why the question, who was smarter than Einstein, is less about dethroning him and more about widening the lens. It's about realizing that genius isn't just one topping on the pizza. It's a whole menu of flavors, and depending on your taste buds, someone else might be the real champion. Einstein deserves his spot, but so do Newton, Curie, Tesla, Noether, Ramanujan, Turing, and countless others whose brilliance doesn't fit neatly into one number. The way we measure smartness changes the story we tell, and maybe the real lesson is that there's no single yardstick for human brilliance at all. So the next time someone drops the old cliché, "Wow, you're such an Einstein," remember that it's only half the picture. You might be a Curie in disguise, a Turing in training, or a Da Vinci waiting to doodle helicopters. Smartness isn't just a number, it's a spectrum of talents, and history proves there's more than one way to bend the universe. If Albert Einstein is the pop culture king of genius, then Isaac Newton is the OG brainiac, the scientist who basically built the playground that every physicist since has been running around in. Newton's name doesn't get tossed around as casually as Einstein's these days, but if we're talking sheer intellectual horsepower and long-lasting impact, Newton might just win the crown. He's the gravity guy, the calculus guy, the laws of motion guy, and the reason modern science has the foundation it does. Without him, Einstein would have been floating in theoretical space with nothing to stand on. The story everyone remembers is the apple. Newton supposedly sat under a tree, an apple fell on his head, and bam, gravity was discovered. That tale is mostly legend, but it's rooted in a kernel of truth. Newton himself said he began thinking about why apples fall straight down and not sideways, and whether the same force that pulls apples could also pull the moon. That question, simple and almost childlike, was the seed that grew into the theory of universal gravitation. Newton realized that the force tugging fruit toward the ground was the very same force guiding planets around the sun. With one idea, he united heaven and earth, showing that the same rules applied to falling objects and celestial bodies. That's not just smart, that's world-shattering. He turned everyday observations into the architecture of the cosmos. But Newton didn't stop with gravity. He also laid down the 3 laws of motion, which are so ingrained in science that every high school student can rattle them off, even if they secretly hated physics class. An object in motion stays in motion unless acted on by an outside force. Force equals mass times acceleration. For every action, there's an equal and opposite reaction. Simple on the surface, but those laws are the backbone of mechanics. They explain why rockets launch, why cars crash, why balls bounce, and why you fly backward if you try to jump off a skateboard. They're so fundamental that engineers still use them to design everything from roller coasters to space shuttles. Think about that. Newton wrote them down in the 1600s, and 4 centuries later, they're still at work every time you hit the brakes in traffic. And then there's calculus, the subject that has traumatized generations of students but also built our modern world. Newton, working in isolation during the plague years, basically invented calculus because the math of his time wasn't strong enough to describe the motion of planets or changing quantities. Imagine being stuck at home during a lockdown and deciding, you know what, I'll just create an entirely new branch of mathematics. That's Newton. Calculus allows us to model change, growth, acceleration, and countless real-world processes. Without it, you wouldn't have modern physics, engineering, economics, or even computer graphics. Every time you watch a Pixar movie or use GPS, you're watching calculus flex its muscles. Newton didn't just solve problems, he created the tools to solve problems no one had even thought of yet. But Newton's genius wasn't just in solving equations, it was in the way he thought about the universe. Before him, nature was often explained with philosophy, speculation, or mystical ideas. Newton brought rigor. He insisted on measurable, testable, mathematical descriptions. He took the universe out of the realm of poetry and into the realm of equations. His book, Philosophia Naturalis Principia Mathematica, usually shortened to Principia because nobody has time for that full Latin title, is often called one of the most important scientific works ever written. Published in 1687, it laid out the laws of motion and gravitation, supported with mathematics that blew his contemporaries' minds. It wasn't just a book, it was the instruction manual for the universe. To this day, physicists still call it the foundation of classical mechanics. If science is a skyscraper, Newton poured the concrete and laid the steel beams. Of course, Newton wasn't perfect. He was famously grumpy, secretive, and kind of petty. He got into brutal academic feuds, most famously with German mathematician Gottfried Wilhelm Leibniz over who really invented calculus. Both developed it independently, but Newton's supporters launched attacks on Leibniz, and the rivalry turned vicious. Newton was also deeply interested in alchemy and biblical prophecy, spending years on pursuits that today we'd call pseudoscience. But here's the thing. Genius doesn't mean flawless. It means producing ideas so revolutionary that they overshadow the quirks, grudges, and rabbit holes. Even when Newton went down strange paths, his core contributions were so massive that they redefined human knowledge forever. What's remarkable about Newton is how much of modern science still rests on his shoulders. Einstein himself acknowledged that he was standing on the shoulders of giants, and Newton was the biggest giant of them all. General relativity may have replaced Newton's laws at extreme scales, near black holes, for instance. But in everyday life, Newton's mechanics are still accurate enough to launch spacecraft and design skyscrapers. NASA still uses Newton's equations to calculate rocket trajectories. Engineers still rely on his principles to build bridges. If Einstein gave us the weird rules of the cosmic casino, Newton gave us the sturdy playbook we still use for most of the game. Think about the impact. Newton's work didn't just change physics, it transformed the world. His laws allowed the Industrial Revolution to flourish, giving rise to machines, engines, and technologies that reshaped societies. His math laid the groundwork for modern engineering and economics. His scientific method of combining observation, experimentation, and math inspired centuries of discovery. If you measure genius by impact, Newton's fingerprints are everywhere, in your phone, in your car, in every building, plane, or medical device. He might not be as trendy as Einstein in pop culture, but his influence is arguably deeper and broader. And let's not forget the sheer audacity of his ideas. To say that the same invisible force pulls apples and planets, that's a conceptual leap so bold it still feels shocking. Before Newton, people thought of Earth and the heavens as separate realms. After Newton, they were united under one set of laws. He didn't just solve problems, he rewrote humanity's place in the cosmos. Suddenly, the universe wasn't chaos. It was order, elegance, and predictability. That worldview set the stage for everything from astronomy to engineering to space travel. Newton gave humanity a key to unlock the universe, and we're still using it today. So was Newton smarter than Einstein? That depends on how you measure. Einstein redefined space, time, and gravity at the cosmic scale. Newton explained motion, force, and gravity in a way that worked for everything we could see and touch. Einstein needed advanced mathematics others developed to formalize his theories, while Newton invented calculus himself just to get his ideas out. Einstein had the advantage of standing on Newton's shoulders, while Newton had to carve his path almost from scratch. If intelligence is measured by raw originality and laying foundations, Newton makes a strong case for being the smarter of the two. Culturally, though, Newton doesn't have the same playful image as Einstein. He wasn't quirky or funny. He was serious, brooding, and often combative. You won't see Newton's face on posters with a goofy tongue-out expression. You won't see Halloween costumes of Newton wigs flying off the shelves. But that doesn't diminish his genius. If Einstein is the rock star of science, Newton is the architect who built the stadium. One dazzled the crowd, the other made sure the stage didn't collapse. Without Newton, Einstein might never have had a platform to shine. And here's the fun part. We don't have to pick one. Comparing Newton and Einstein is like comparing Shakespeare and the Beatles. Both reshaped culture in their own ways, both were geniuses in different arenas, and both left legacies that will echo for centuries. Newton was the gravity guy, the calculus guy, the motion guy, the OG brainiac who set the stage for everything that followed. Einstein may have captured the world's imagination, but Newton built the intellectual universe we still live in. So the next time someone says Einstein is the smartest person who ever lived, just remember there's a man with a wig and a quill pen quietly raising his hand from the 17th century. He might not have had wild hair, but he had wild ideas that still underpin science today. And if we're talking OG geniuses, Newton isn't just in the conversation. He might be the one who wrote the conversation in the first place. If Einstein had the messy hair and Newton had the apple, Marie Curie had something far more dangerous. Glowing rocks that literally changed the world. She wasn't just a scientist. She was a trailblazer, a pioneer, and a survivor who turned curiosity into history-making discoveries. And unlike Einstein, who is remembered as the pop culture poster child of genius, Curie was the one who quietly stacked up achievements so unprecedented that no one has been able to touch them since. First woman to win a Nobel Prize, the first person to win 2 Nobel Prizes, and the only person ever to win in 2 different sciences, physics and chemistry. That's right, Einstein can keep his relativity. Curie literally bent the periodic table to her will. If we're comparing brains and resilience, she gives the men a serious run for their money. Marie Curie's story starts with her not even being allowed to study where she wanted. Born Maria Skłodowska in Warsaw, Poland, in 1867, she grew up in a world where women were told education was for men. Universities were closed to her. But did that stop her? Nope. She attended a secret floating university where Polish women gathered to learn in defiance of the rules. She studied in secret, worked as a governess to save money, and eventually made her way to Paris, where she studied at the Sorbonne. Imagine the determination it takes to fight through financial struggles, cultural barriers, and blatant sexism just to get a chance at science. Already, before any glowing rocks, she was proving herself smarter than her environment, smarter than the limits society tried to put on her. In Paris, she met Pierre Curie, who wasn't just her husband, but her scientific partner. Together, they tackled the mysterious phenomenon of radiation, a term she actually coined. At the time, scientists had noticed that uranium emitted energy without any external trigger, but nobody knew why. The Curies dug in, isolating new elements from tons of ore. And when I say tons, I mean literal tons. Marie spent years stirring massive vats of pitch blende, a uranium-rich ore, boiling, separating, and analyzing tiny amounts of mysterious substances. Her determination was almost superhuman. In 1898, the Curies announced the discovery of polonium, named after Marie's homeland of Poland, and later that same year, they discovered radium. Both elements glowed faintly in the dark, like eerie lanterns. In the age before fluorescence was trendy, Marie Curie's lab had a literal radioactive glow. These discoveries were groundbreaking. Not only did they add new elements to the periodic table, but they also unlocked a completely new understanding of matter. Up until then, atoms were thought to be indivisible, eternal building blocks. Curie's work helped prove that atoms themselves could change, decay, and release energy. Radioactivity wasn't just a curiosity, it was a window into the very heart of matter, a force that could power medicine, industry, and eventually nuclear energy and weapons. Without Curie, there's no nuclear age, no radiation therapy for cancer, no X-rays as we know them today. Her impact stretches across physics, chemistry, and medicine. In 1903, Curie, her husband Pierre, and Henri Becquerel won the Nobel Prize in physics for their work on radiation. But here's the scandal. The Nobel Committee originally intended to give the prize only to Pierre and Becquerel, leaving Marie out entirely because, well, sexism. Pierre himself had to insist that Marie's name be included, pointing out that she had done as much work, if not more, than he had. That intervention got her the recognition she deserved, but it was only the beginning of a lifetime of fighting for credit. Tragedy struck in 1906 when Pierre was killed in a street accident, leaving Marie a widow with 2 daughters. Most people would have collapsed under the grief. Marie? She stepped into his professorship at the Sorbonne, becoming the first woman to teach there. She carried on their research, expanding her studies of radium and its properties. In 1911, she won her second Nobel Prize, this time in chemistry, for discovering radium and polonium and studying their properties. No one else has ever matched that feat. 2 Nobels in 2 different sciences. Not Einstein, not Newton, not anyone. If genius is measured by resilience and sheer accomplishment, Curie left everyone else in her radioactive dust. Of course, working with radioactive materials came at a cost. At the time, no one fully understood the dangers of radiation exposure. Marie handled radium with her bare hands, kept test tubes of glowing substances in her desk drawer, and even carried them in her pockets. Her notebooks from that era are still so radioactive that they're stored in lead-lined boxes today. She suffered from chronic illnesses, likely caused by radiation exposure, and ultimately she died in 1934 from aplastic anemia, almost certainly the result of her lifetime of work with radioactive elements. In a tragic twist, the very discoveries that made her famous also cut her life short. But even in that, her story is a symbol of dedication. She literally gave her life to science. Her work wasn't just in the lab. During World War I, Curie recognized that soldiers on the battlefield needed quick medical imaging. She helped equip ambulances with mobile X-ray machines and even train nurses and technicians to use them. She personally drove to the front lines to make sure the technology was saving lives. Imagine being a world-class scientist, already a Nobel laureate, and then deciding to personally roll up your sleeves and bring your discoveries to wounded soldiers. That's not just intelligence, that's compassion paired with brilliance. And here's the part that really drives home why Curie belongs in any discussion of geniuses smarter than Einstein. Einstein revolutionized physics, sure, but he never had to fight his way into classrooms. He never had to argue with Nobel committees to recognize his name. He never had to work with his hands stirring ore for years to isolate a fraction of a gram of a new element. Curie had to push against systemic barriers every step of the way, and she still managed to achieve world-changing breakthroughs. Intelligence isn't just about what you know, it's about what you overcome. And by that measure, Curie was extraordinary. Her legacy endures not only in her scientific discoveries, but also in the way she paved the path for women in science. Today, she's an icon, but at the time, she was often dismissed, criticized, or outright ignored. Even after her second Nobel, the press attacked her for her personal life, focusing more on her relationships than her achievements. Yet she persisted, teaching, researching, and mentoring the next generation. Her daughter Irène Joliot-Curie even won a Nobel Prize herself, continuing the family tradition of radioactive brilliance. That's not just a legacy, that's a dynasty of genius. When we measure genius, we often get caught up in equations, theories, and IQ scores. But Curie forces us to expand our definition. Genius is also perseverance, pioneering, and breaking barriers. Genius is the ability to not just imagine new worlds, but to fight for the right to create them. Curie's discoveries reshaped our understanding of matter, gave us tools to fight disease, and pushed humanity into the nuclear age. Her name might not be used as a synonym for smartness the way Einstein's is, but her record speaks louder than any pop culture catchphrase. So the next time someone says Einstein is the ultimate genius, ask them this: did Einstein win 2 Nobels in 2 different sciences? Did Einstein pioneer an entirely new branch of physics while battling systemic sexism? Did Einstein invent words like radioactivity and personally risk his health to make discoveries? No? Then maybe, just maybe, the radioactive trailblazer deserves a brighter spotlight. Because if smartness is measured by resilience, innovation, and sheer impact, Marie Curie doesn't just stand beside Einstein, she stands taller, glowing like the elements she discovered. If Newton gave us gravity and Einstein gave us relativity, then Nikola Tesla gave us dreams. Not just ordinary dreams, but wild, electrified visions of a future so strange that even today, parts of it feel like science fiction. He wasn't the guy tinkering at the edges of what was already known. He was the one peering into tomorrow, sketching technologies that wouldn't exist for decades, maybe even centuries. He imagined a world of wireless power, global communication, self-operating machines, and renewable energy long before anyone else. Some of it he built, some of it stayed locked in notebooks. All of it added up to a kind of brilliance that feels almost otherworldly. If Einstein was the careful mathematician of the cosmos, Tesla was the electric dreamer who tried to bend reality to match his imagination. Tesla's story begins in 1856, in what is now Croatia. From the start, he showed signs of a brain wired differently than most. He claimed to have vivid visions, flashes of inspiration where inventions appeared fully formed in his mind. While other inventors sketched and tinkered, Tesla could run experiments entirely in his imagination, testing different designs in his head until he was satisfied. He called it visualization, but it was basically a superpower. By the time he was a young man, he was already obsessed with electricity, convinced it would define the future of civilization. That conviction never left him. His most famous invention, the alternating current system, changed the world. In the late 1800s, electricity was a wild frontier. Thomas Edison pushed direct current, DC, but it was inefficient over long distances. Tesla's alternating current, AC, could travel miles with little loss, powering entire cities. The war of currents between Edison's DC and Tesla's AC turned into a legendary showdown. Edison launched smear campaigns, electrocuted animals in public demonstrations to make AC look dangerous, and even invented the electric chair as a PR stunt. Tesla, meanwhile, kept refining his AC system, working with industrialist George Westinghouse. In the end, AC won, and the modern electrical grid still runs on Tesla's vision. Every time you flip a light switch, charge your phone, or watch a video, you're using Tesla's electricity. But Tesla didn't stop with AC power. His mind raced far beyond the present. In 1891, he patented the Tesla coil, a device that could generate high-voltage electricity and produce dramatic arcs of lightning. While it's mostly a scientific showpiece today, Tesla saw it as a step toward wireless transmission of power. He imagined towers that could beam electricity across the globe, letting people light their homes, power their machines, and communicate instantly without wires. He actually built one, the Wardenclyffe Tower on Long Island, designed to transmit both power and information through the atmosphere. It looked like something out of a steampunk fantasy. A massive tower capped with a copper dome, buzzing with ambition. Investors didn't understand it, funding dried up, and the tower was eventually demolished. But the dream, that's still alive. Today's experiments with wireless charging, satellite-based internet, and renewable grid systems all echo Tesla's vision of global wireless power. Tesla also foresaw technologies that wouldn't exist until long after his death. In interviews, he described concepts that sound eerily like smartphones and the internet, handheld devices that could instantly connect people across the world, transmitting voice, images, and data. He envisioned self-driving machines, drones, and robots that could replace human labor. He even talked about harnessing renewable energy from natural sources like wind, water, and sunlight to power civilization sustainably. Reading Tesla's predictions today feels like peeking at a cheat sheet for the 21st century. He didn't just think outside the box, he lived on a different plane entirely. Of course, Tesla's genius came with a dose of eccentricity. He had odd habits and fears, including an intense dislike of pearls and a fixation on the number 3. He was famously celibate, believing romantic relationships would distract him from science. He fed pigeons in New York City, sometimes spending his last dollars on seeds for them rather than food for himself. He claimed to receive messages from extraterrestrials after detecting mysterious radio signals, though modern scientists think he was probably picking up natural cosmic phenomena. To his fans, these quirks only make him more fascinating. To his rivals, they made him easy to dismiss as a mad scientist. But beneath the eccentricities was a mind burning with ideas far too advanced for his time. Tesla's relationship with other scientists also highlights the complexity of his genius. While Edison hogged the spotlight with flashy demonstrations and clever marketing, Tesla was the quiet visionary who often got overlooked. While Einstein was revolutionizing physics with relativity, Tesla was busy imagining technologies that would transform daily life. The difference was partly in focus. Einstein was a theoretical physicist, Tesla an applied inventor, but it was also about recognition. Einstein had academic institutions behind him, while Tesla often worked alone or struggled with investors. In terms of cultural branding, Einstein became the face of genius. Tesla became the cautionary tale of the misunderstood visionary. Yet in hindsight, so many of Tesla's ideas have proven true that his brilliance looks prophetic. What makes Tesla fascinating isn't just what he invented, but what he imagined. Plenty of geniuses solved the problems in front of them. Tesla was solving problems 100 years down the road. Wireless communication, renewable energy, automation. He was talking about all of it in the 1890s. Imagine being so ahead of your time that your peers look at you like you're crazy, only for future generations to realize you were right all along. That's not just intelligence, that's almost time travel. But here's where the story turns tragic. For all his brilliance, Tesla wasn't great with money. He gave away patents, lost funding, and lived much of his later life in poverty. Wardenclyffe Tower never got finished. Investors pulled out. He ended up living in hotels, often unable to pay the bills, sustained more by his dreams than by actual income. He died in 1943, alone in a New York hotel room, while the world rushed forward powered by his inventions, but largely forgetting his name. Einstein's theories were transforming physics, Edison's brand lived on, and Tesla. He was the ghost of a genius, his notebooks scattered, his reputation dimmed. And yet, history has a funny way of correcting itself. Today, Tesla's name is everywhere, slapped on electric cars, tech companies, and memes about how Edison stole his ideas. His reputation has soared, not just because of the cult of personality around him, but because we now see how visionary he truly was. Wireless charging pads. Tesla dreamed of them. Drones. Tesla imagined them. Renewable energy grids. Tesla was begging us to build them a century ago. He didn't just contribute to science. He anticipated the future. That's a flavor of genius even Einstein can't claim. If we measure smartness by raw IQ, Tesla supposedly scored high, though like Einstein, the numbers are mostly speculation. If we measure by creativity, Tesla wins hands down. If we measure by impact, Tesla's inventions and ideas underpin modern electricity, communication, and technology. The tragedy is that he didn't get to see his visions fully realized, but the beauty is that they keep coming true, decade after decade. His brain planted seeds that are still sprouting in labs, factories, and satellites today. So was Tesla smarter than Einstein? Again, it depends how you slice the pizza. Einstein gave us relativity, the cosmic rules of time and space. Tesla gave us alternating current, wireless dreams, and visions of a connected future. Einstein was crowned the genius king, but Tesla was the electric dreamer whose imagination bordered on supernatural. If genius is about bending reality to your will, Tesla may not have finished building his tower, but he built a legacy of ideas that continue to light up the world, literally. The next time you charge your phone without plugging it in, fly a drone through the sky, or stream a video across invisible signals, remember the man who saw it all coming more than a century ago. Einstein may have given us equations for the universe, but Tesla gave us the spark of the future, and that spark is still glowing. When you think of genius scientists, the mind usually jumps straight to the math-heavy titans. Newton scribbling calculus in candlelight, Einstein bending time with equations, Ramanujan pulling infinite series out of thin air. But not every genius needs to bury their brilliance under a mountain of symbols. Some geniuses are quiet observers, people who see patterns hiding in plain sight that everyone else has been ignoring. That's where Charles Darwin comes in. He wasn't flashy with math. He wasn't writing down the theory of relativity or dropping formulas that made physicists swoon. His genius was in noticing, in connecting dots, in looking at nature, birds, finches, tortoises, beetles, and realizing there was a bigger story, one so massive it reshaped biology forever. Darwin didn't just change science, he rewrote how humanity saw itself in the grand tapestry of life. Darwin's story is fascinating because, in some ways, he looked like the least likely candidate for world-shaking genius. Born in 1809, he was the kind of kid who collected beetles and stared at plants while everyone else was probably thinking about careers and money. He tried studying medicine, but couldn't stomach the surgeries. He flirted with becoming a clergyman, more interested in hunting and natural history than sermons. If you were a career counselor in the 1830s, you probably wouldn't have circled his name as most likely to change the entire field of biology. But sometimes, genius doesn't look like a math prodigy scribbling proofs. Sometimes, genius looks like a curious wanderer who refuses to stop asking questions. The big turning point, of course, was the voyage of the HMS Beagle. In 1831, a 22-year-old Darwin boarded a ship for a journey that would last nearly 5 years and cover much of the globe. His official job was as a naturalist, someone to collect specimens, make observations, and generally keep records. What he got was the education of a lifetime. He traveled to South America, the Galapagos Islands, Australia, and more, observing landscapes, fossils, plants, and animals. He filled notebooks with detailed notes and sketches, obsessively cataloguing what he saw. Most people might have come back with cool souvenirs. Darwin came back with the seeds of a theory that would rock the world. The famous story is the finches of the Galapagos. On different islands, Darwin noticed that finches had different beak shapes, each suited to the available food. One island had finches with thick beaks for cracking nuts. Another had slender-beaked finches for picking insects. At first, it was just a curious observation, but then the pattern clicked. What if species weren't fixed and unchanging, as most people believed at the time? What if they adapted to their environment, gradually shifting traits across generations? What if nature itself was the ultimate selector, favoring traits that helped organisms survive and leaving behind those that didn't? In that moment, the idea of natural selection began to crystallize. It wasn't just about birds with funny beaks. It was about the mechanism that explained all of life's diversity. Think about the intellectual leap this required. At the time, most people believed in creationist ideas, that species were created exactly as they are and remained unchanged. Fossils of extinct animals were puzzling oddities, not pieces of a bigger evolutionary puzzle, suggesting that humans, plants, and animals all shared common ancestors. That was practically heresy. And yet Darwin saw what was right in front of everyone's eyes and connected the dots. His insight was that evolution wasn't random chaos. It was a process with rules. Natural selection wasn't guided by divine hand or chance alone. It was the law of nature's workshop. Life adapts. Traits shift. The strong, the adaptable, the fittest, in the sense of fitting best into the environment, survive and pass their genes on. That simple, yet profound idea reshaped not just biology, but philosophy, theology, and culture. It took Darwin years to publish his theory. He gathered evidence obsessively, studying barnacles for 8 years, breeding pigeons to observe variation, and analyzing countless specimens. He built a mountain of data to support his hunch because he knew it would be controversial. And controversial it was. When On the Origin of Species finally hit shelves in 1859, it exploded like a scientific bomb. The book laid out his argument with meticulous logic and evidence, proposing that all species descended from common ancestors through the mechanism of natural selection. It sold out immediately. Scientists debated, clergy fumed, and ordinary readers were fascinated and horrified in equal measure. Darwin had ripped the curtain off the grand mystery of life and shown that the human species wasn't a special creation standing apart, but part of the same evolutionary process as every other creature. That idea was both terrifying and liberating. Here's what makes Darwin's genius so interesting. He didn't invent a new branch of math like Newton. He didn't flip physics upside down like Einstein. He didn't create glowing new elements like Curie. He simply paid attention. He looked at patterns in nature that had been overlooked for centuries and asked the right questions. His brilliance was in making the obvious visible, in seeing connections that were hiding in plain sight. In a way, that's harder than solving an equation. It requires a mindset that's open, patient, and unafraid of conclusions that might shake the foundations of belief. He wasn't the loudest or the flashiest thinker, but his ideas hit deeper than most, and his impact? Enormous. Modern biology is built on Darwin's foundation. Genetics, ecology, medicine, even computer science use concepts inspired by evolution. Antibiotic resistance, for example, makes sense only through natural selection. Viruses like influenza or COVID-19 mutate and evolve, with the fittest strains surviving. Agriculture relies on selective breeding, a human-guided version of Darwin's principle. Conservation biology, studying how species adapt or fail to adapt to climate change, owes everything to Darwin. His theory doesn't just explain the past, it predicts the future. Life keeps changing, and natural selection keeps driving it. Darwin's insights gave us the blueprint to understand that endless churn. Of course, Darwin's ideas weren't perfect. He didn't know about DNA, genes, or the molecular mechanisms of inheritance. Gregor Mendel's work on genetics, happening around the same time, wasn't widely recognized until decades later. Darwin's theory explained the what and the how of evolution, but didn't have the full why at the molecular level. But genius doesn't mean solving everything. It means moving the conversation forward so far that the next generations can fill in the details. Darwin gave us the framework, and modern science has been building on it ever since. What makes Darwin particularly impressive is his patience and humility. He sat on his theory for decades, refining it because he knew how controversial it would be. He wasn't rushing to fame. He wanted the evidence to be airtight. In fact, he might have delayed forever if not for Alfred Russel Wallace, another naturalist who independently came up with the idea of natural selection. When Darwin realized someone else was about to publish a similar theory, he finally pulled his work together and released On the Origin of Species. Imagine having an idea so radical it could upend centuries of belief, and instead of shouting it from rooftops, you quietly study pigeons for years, making sure every piece fits. That kind of patience is its own flavor of genius. Darwin's work also shows that genius isn't always about solitary inspiration. It's about collaboration, context, and timing. His voyage on the Beagle gave him access to global biodiversity. His correspondence with other scientists broadened his understanding. His knowledge of geology, fossils, and breeding practices all fed into his theory. He wasn't a lone wolf. He was a connector, someone who integrated ideas from multiple fields into one grand vision. That integration, that ability to weave threads into a tapestry, is genius of a different kind. So, was Darwin smarter than Einstein? Again, it depends on the topping you pick. If you want mathematical brilliance, Einstein wins. If you want cosmic theories, Einstein dazzles. But if you want someone who reshaped the way humanity understands life itself, Darwin takes the crown. He wasn't about equations, he was about insight. He showed us that genius isn't only about scribbling formulas on a blackboard. Sometimes it's about staring at a bird, noticing its beak, and realizing you've just uncovered the engine driving all of biology. Today, Darwin's name is synonymous with evolution. His face is on money, his books are still read, and his ideas ripple through every branch of science. But more importantly, his genius lives in the way we understand ourselves. Thanks to Darwin, we know we are part of a vast, interconnected tree of life. We're not separate from nature. We are nature. That realization is humbling, unsettling, and inspiring all at once. Darwin proved that sometimes the smartest move isn't inventing new math or building new machines. Sometimes it's looking at the world with fresh eyes, asking uncomfortable questions, and daring to follow the answers wherever they lead. That's why he's the evolutionary revolutionary, the genius who connected the obvious dots no one else had the courage to connect, and in doing so, changed biology forever. If you want a story that proves genius doesn't always need classrooms, blackboards, or fancy European universities, look no further than Srinivasa Ramanujan. This man was the ultimate self-taught brainiac, a mathematician whose theorems are still baffling experts today. While Einstein was off bending space and time with relativity, Ramanujan was bending mathematics itself, pulling out equations that seemed to fall from another dimension. And the kicker? He did most of it with almost no formal training, scribbling formulas in notebooks that would later become treasure maps for modern mathematicians. When Einstein once admitted that he couldn't follow advanced math of this level, he wasn't being modest, he was being real. Ramanujan's mind operated on a plane most people can't even imagine. Born in 1887 in Erode, India, Ramanujan didn't exactly have the upbringing of a typical prodigy. He grew up poor, with limited access to schooling, and for a long time, he wasn't even considered a promising student. He excelled in math early, but he struggled in other subjects. He failed exams because he spent all his time obsessing over equations instead of history or English. In a society that prized well-rounded students, Ramanujan looked like a failure. But in reality, his brain was laser-focused on one thing: mathematics. He discovered a dusty old book, a synopsis of elementary results in pure and applied mathematics, written by G.S. Carr. It contained thousands of formulas with little explanation. For most students, it would have been overwhelming. For Ramanujan, it was fuel. He devoured the formulas, experimented with them, extended them, and began creating his own. He wasn't learning math the normal way. He was teaching himself to see deeper patterns that others couldn't. By his late teens, Ramanujan was already writing down results that would stump professors. He filled notebooks with identities, series, and functions, many without proofs, just raw results. To him, math wasn't about laboriously working through logic. It was about intuition, visions, and what he once described as flashes from the goddess Namagiri, whom he believed inspired him. Whether you call it divine inspiration or pure genius, the results were staggering. He developed infinite series expansions, partition functions, and formulas for pi that remain astonishingly accurate. One of his formulas for calculating pi was so efficient that it's still used in modern computing, even in algorithms that calculate billions of digits. Imagine a man sitting in India, half-starving, writing formulas by candlelight that would one day power supercomputers. That's not just smart, that's legendary. The turning point came when Ramanujan started writing letters to British mathematicians, sharing his work. Most ignored him. His results looked too strange, too unconventional, as if they couldn't possibly be real. But in 1913, his letter reached G.H. Hardy, a prominent mathematician at Cambridge. Hardy opened the letter, saw pages filled with bizarre formulas, and at first thought it was a prank. But as he studied them, he realized something incredible. These weren't random scribbles. They were deep, original, and many were true, results so advanced that even experts hadn't discovered them yet. Hardy later said it was like seeing the work of another Euler, one of history's greatest mathematicians. Imagine being so smart that your unsolicited mail changes the trajectory of mathematics forever. Hardy arranged for Ramanujan to come to Cambridge, and soon the world had one of the most famous collaborations in the history of math. Hardy, the methodical, logical British mathematician, and Ramanujan, the intuitive, almost mystical genius from India. Together, they published groundbreaking papers on number theory, infinite series, and modular forms. Hardy tried to teach Ramanujan the formal rigor of proofs, while Ramanujan dazzled Hardy with results that seemed to come out of thin air. Hardy once rated himself as a genius of about 25, on a scale where the likes of Newton would be 100. He rated Ramanujan at 100. That's how unmatched Ramanujan's brilliance appeared, even to one of the best mathematicians of his time. But genius doesn't protect you from hardship. Life at Cambridge was grueling for Ramanujan. The cold English climate, cultural isolation, and wartime food shortages took a toll on his health. He was a strict vegetarian, which made it difficult to find proper nutrition in England. He worked obsessively, often ignoring his own physical needs, pouring everything into his notebooks. In 1918, at just 31 years old, he was elected a Fellow of the Royal Society, one of the highest honours in science. He was also elected a Fellow of Trinity College, Cambridge, an incredible achievement for someone who had been dismissed as a failing student back home. But his health continued to decline. In 1920, at the age of only 32, Ramanujan died, leaving behind a body of work that would keep mathematicians busy for generations. And here's where the story gets even more unbelievable. At his death, Ramanujan left behind several notebooks filled with formulas, many of them without proofs. For decades, mathematicians pored over them, proving results, discovering new insights, and finding applications in fields Ramanujan could never have imagined. His work anticipated developments in string theory, quantum physics, and computer science. His partition function insights, which count the number of ways integers can be expressed as sums, turned out to have deep connections with modular forms and black hole entropy in modern physics. That's right, a man working with no formal training, guided only by intuition and inspiration, scribbled formulas that would one day help physicists understand the fabric of the universe. That's not just genius, that's prophetic. What makes Ramanujan so fascinating is how different his style of genius was compared to someone like Einstein. Einstein relied on thought experiments, logic, and mathematics developed by others to formalize his theories. He was brilliant, but his brilliance fit within a recognizable framework. Ramanujan, by contrast, didn't work like other mathematicians. He didn't slog through proofs, he didn't build from first principles. He leapt, he intuited, he wrote down results with little explanation, as if they had been whispered to him by the universe itself. And while Einstein admitted his limits in advanced mathematics, Ramanujan seemed limitless, playing with infinite series and modular functions like they were toys. If you measure genius by sheer originality and raw creative power, Ramanujan stands in a category of his own. Of course, skeptics at the time sometimes dismissed him, arguing that intuition without proof was unreliable. But time has vindicated him. Most of his results have been proven correct. Some are still being unraveled today. Modern mathematicians continue to publish papers based on Ramanujan's notebooks, discovering new applications in areas from computer algorithms to string theory. A century later, his legacy isn't fading, it's growing. Few geniuses can claim that their unfinished scribbles would inspire discoveries 100 years after their death. Ramanujan's story also forces us to rethink what it means to be smart. He didn't come from privilege. He didn't have access to the best schools or professors. He wasn't trained in the Western tradition of rigorous proofs. But his mind soared anyway, powered by curiosity, persistence, and perhaps a little bit of mysticism. Genius doesn't always look like a polished professor in a lab coat. Sometimes it looks like a self-taught mathematician in India, writing formulas in the margins of a borrowed notebook, too poor to buy paper, too obsessed with numbers to do anything else. And that's why, when people ask if anyone was smarter than Einstein, Ramanujan's name belongs in the conversation. Einstein changed physics, no question. But Ramanujan expanded the boundaries of mathematics itself, without training, without resources, and without recognition until late in his short life. Einstein admitted he couldn't follow math like this, and that humility is telling. Because genius isn't one size fits all. Einstein gave us relativity, Ramanujan gave us infinity. Today, Ramanujan is celebrated as one of the greatest mathematical minds in history. Movies, books, and biographies tell his story. Statues honor him. Scholars continue to explore his legacy. But the true measure of his genius isn't the honors. It's the fact that math he dreamed up under candlelight still guides modern science. His equations whisper across time, reminding us that brilliance can come from anywhere, and that sometimes the smartest person in the room is the one nobody expected. So, if you ever doubt that genius can thrive without classrooms, without privilege, without resources, just remember Srinivasa Ramanujan, the self-taught genius who reached into the infinite and came back with equations still blowing minds today. If genius sometimes gets measured by who ends up on the front cover of textbooks, then Rosalind Franklin is proof that history doesn't always give the crown to the right person. Her work was the key to one of the greatest scientific discoveries of the 20th century. The double helix structure of DNA, the molecule of life itself. Without her X-ray images, the spiral staircase of heredity might have remained hidden much longer. Yet, when people tell the story of DNA, they usually say Watson and Crick, maybe throw in Maurice Wilkins, and then stop there. Franklin's brilliance was overlooked for decades, shoved into the footnotes, when in reality, she should have been at the top of the page. Hers was a genius of precision, patience, and vision, and the world only realized how essential she was long after her death. Rosalind Franklin was born in 1920 in London into a family that valued education. From the start, she showed an affinity for detail and analysis, traits that would later make her an extraordinary scientist. She studied chemistry at Cambridge University, a field where women were still rare, and threw herself into physical chemistry, a discipline notorious for being difficult and demanding. By her 20s, she was already making breakthroughs in understanding the structure of carbon and coal, research that would later prove vital during World War II for creating better gas masks. That alone would have been a career achievement for most scientists. But Franklin's story was just getting started. Her true genius revealed itself when she mastered a technique known as X-ray crystallography. Now, this is not the kind of science that looks dramatic in a movie. You don't get sparks flying or test tubes bubbling. Instead, you painstakingly prepare tiny crystals of a substance, bombard them with X-rays, and then analyze the patterns of light and dark spots that appear on photographic film. It looks like a bunch of blurry dots, but hidden in those patterns are the fingerprints of atomic structure. It takes a rare mix of technical skill, mathematical ability, and artistic insight to interpret those patterns correctly. Franklin had all three in spades. She wasn't just good at crystallography, she was world-class, capable of coaxing out details others missed. In 1951, Franklin joined King's College London, where she began working on the structure of DNA. At the time, scientists knew DNA was important for heredity, but they didn't know its shape. Was it a helix, a ladder, a tangled mess? The race was on to figure it out, with teams at King's and Cambridge competing, along with groups in the US. Franklin set to work with her X-ray crystallography, taking painstakingly clear images of DNA fibers. Her photos were sharper and more detailed than anything produced before. Among them was one image that would become legendary. Photo 51. Photo 51 was the smoking gun. Taken by Franklin's student Raymond Gosling under her direction, it showed a clear X-shaped pattern that screamed helix to anyone who knew how to read it. The distances between spots gave crucial measurements about the width of the molecule and the spacing of its twists. Franklin herself was cautious, preferring to gather more data before jumping to bold conclusions. But her photograph contained the blueprint of DNA's double helix. Unfortunately, she didn't get the chance to publish first. Here's where the story gets controversial. Maurice Wilkins, a colleague at King's, shared Franklin's photo 51 with James Watson without her permission. Watson and his partner Francis Crick were at Cambridge, struggling to build a model of DNA. The moment Watson saw the photo, the pieces clicked. He later admitted it was the critical data they needed to confirm the double helix. Using Franklin's photograph and other details from her work, Watson and Crick rushed to finish their model and published their iconic paper in Nature in 1953. They acknowledged Franklin in a footnote, but did not credit her as a co-author. When the Nobel Prize in Physiology or Medicine was awarded in 1962 for the discovery of DNA structure, it went to Watson, Crick, and Wilkins. Franklin, who had died in 1958 at the age of 37, was left out. Nobel Prizes aren't awarded posthumously, but even so, her central role had already been buried under the narrative that Watson and Crick were the heroes of the story. This erasure is one of the great injustices of science history. Franklin's X-ray crystallography, her careful data collection, and her interpretation laid the groundwork for the double helix. Watson and Crick were brilliant in their own right, but without Franklin's photo, their model might have been speculation rather than confirmation. In many ways, her insight outshined her contemporaries. She had the technical skill and discipline to produce the evidence, while others relied more on bold guesswork. Genius isn't just about flashy breakthroughs. It's about precision, rigor, and knowing when the data speaks for itself. Franklin embodied that. Her brilliance didn't end with DNA. After leaving King's College, Franklin worked on the structure of viruses, particularly the tobacco mosaic virus. She used her crystallography expertise to show how the virus's protein coat was arranged in a helical structure, work that became foundational for molecular biology. She also investigated the poliovirus, contributing insights that helped future scientists understand viral structures. Even in her short career, cut off by ovarian cancer at 37, Franklin left behind a body of work that touched multiple fields and continues to influence science today. When we talk about smarter than Einstein, Franklin absolutely deserves to be in the conversation. Not because she was solving relativity, but because her genius was a different flavor. Einstein imagined the cosmos bending and stretching. Franklin revealed the microscopic blueprint of life itself. Einstein is remembered for his wild hair and iconic quotes. Franklin, unfairly, was remembered as a supporting character in someone else's story. But in reality, her intellect, her contributions, and her sheer ability to see what others missed were every bit as transformative. She reshaped biology, medicine, and genetics in a way that underpins everything from ancestry tests to CRISPR gene editing today. The tragedy of Franklin's overlooked genius has become a rallying cry for recognizing women in science. For decades, her name was absent from the DNA story, but modern historians, scientists, and educators have fought to restore her rightful place. Schools and labs are named after her. Books and films tell her story. And her legend grows not just because of what she did, but because of what it says about science itself. That brilliance can be ignored if bias blinds us, but truth eventually shines through. Imagine a world where Franklin lived longer, published more, and got the recognition she deserved in her lifetime. Would we see her as the Einstein of biology today? Quite possibly. But even without that recognition, her work stands on its own as a monument to human intelligence. Every biology textbook that draws a double helix, every researcher who studies DNA, every medical breakthrough that relies on genetics owes something to her. That's impact at a level most scientists only dream of. Rosalind Franklin's story teaches us that genius isn't just about discovery, it's about resilience. She worked in an environment that often dismissed her, overshadowed her, and sometimes even undermined her. Yet she kept producing work of the highest caliber. She didn't chase fame or headlines. She chased truth with a rigor that demanded respect. Her X-ray crystallography wasn't just a technique, it was a lens that let humanity peer into the deepest secrets of life. So the next time you hear someone rattle off the names Watson and Crick, remember the woman whose photograph actually proved the double helix. Remember the scientist who outshined many contemporaries with her clarity, precision, and brilliance. Remember Rosalind Franklin, the X-ray visionary whose genius was overlooked for decades, but whose legacy now glows as brightly as radium in the dark. If genius is about being multi-talented, then Leonardo da Vinci isn't just on the list of smartest humans ever. He's sitting at the top, waving at everyone else like, "Nice job with your one subject, but I'll take all of them, thanks." While Einstein dazzled with relativity and Newton reigned over gravity, Leonardo was painting masterpieces, designing futuristic machines, dissecting corpses to map anatomy, sketching city plans, and doodling helicopters centuries before helicopters were real. He was the definition of a Renaissance brain, a one-man Google search engine before Google existed. If Einstein makes us think of cosmic equations, Leonardo makes Einstein look like a specialist, a man with one brilliant toolkit, while he himself was juggling 20. Born in 1452 in Vinci, Italy, Leonardo was technically illegitimate, the son of a notary and a peasant woman. That meant no fancy university education, no easy inheritance, and no straightforward career path. But he did have something else: boundless curiosity, and the ability to turn curiosity into action. As a teenager, he apprenticed in Florence with Andrea del Verrocchio, a painter and sculptor, where he learned not only how to paint, but also how to sculpt, draft, and work with machines. By the time most kids today would be stressing about finals, Leonardo was already blending art and engineering in ways that made him stand out. His genius wasn't confined to one lane. From the start, he was speeding through all of them. Let's start with painting, because if Leonardo had only painted, he'd still be remembered as one of the greatest artists of all time. The Mona Lisa is arguably the most famous painting in history, her mysterious smile studied endlessly by tourists, scholars, and conspiracy theorists alike. The Last Supper is an icon of religious art, famous for its composition and detail, even though centuries of damage and restoration have blurred the original. His use of sfumato, the soft blending of edges and tones, was revolutionary, creating a realism and depth that set new standards in art. But here's the thing. Leonardo didn't just paint beautifully. He painted scientifically. He studied light, anatomy, and perspective with obsessive detail, using his knowledge of the real world to elevate art into something more than decoration. He wasn't just making pictures. He was blending observation with creativity, turning brushstrokes into a visual science experiment. But then, while most painters would rest on their artistic laurels, Leonardo would turn around and start sketching designs for flying machines, armored vehicles, and futuristic bridges. His notebooks are filled with inventions that look like they belong in a sci-fi movie. Helicopters powered by twisted linen ropes, tanks shaped like giant turtles, scuba diving suits for underwater exploration, even plans for a mechanical robot knight that could move its arms and sit up on its own. Some of his ideas were impractical given the materials of his time, but the sheer fact that he imagined them is staggering. He wasn't just ahead of his contemporaries, he was centuries ahead. When people call him the ultimate visionary, they mean it literally. He envisioned things the world wouldn't actually build until the 19th or 20th century. And then there's his work in anatomy. While others shied away from the grim reality of dissection, Leonardo dove in. sketching human muscles, bones, organs, and nerves with an accuracy that rivals modern textbooks. He performed dozens of dissections, carefully drawing the heart's chambers, the folds of the brain, the structure of the fetus in the womb. His anatomical drawings were so precise that some modern surgeons still admire their accuracy. He wasn't doing this for fame or medical practice. He was doing it because he wanted to know how the human machine worked. Genius isn't always about building rockets or splitting atoms. Sometimes it's about asking, what's under the skin? And then answering with a level of detail that blows everyone else out of the water. Leonardo also dabbled in geology, botany, architecture, hydraulics, and military engineering. He studied the flow of water and how rivers shaped landscapes. He analyzed plants with the same eye for detail he used on bones. He designed ideal cities with organized streets and sanitation systems that would have put medieval towns to shame. He even sketched ideas for giant crossbows and elaborate fortresses. If there was a field of knowledge available in the Renaissance, Leonardo dipped his brush, quill, or scalpel into it. And if there wasn't, he invented it. That's why calling him a polymath almost feels like an understatement. He wasn't just many things. He was all the things. What sets Leonardo apart isn't just the range of his talents, but the way he connected them. He didn't treat art and science as separate. To him, they were two halves of the same coin. His dissections informed his paintings. His studies of light helped him understand optics. His engineering sketches were influenced by his understanding of anatomy and motion. He saw patterns across disciplines that most people would never think to connect. Today, we celebrate specialists who master one field, but Leonardo's genius was in refusing to specialize. He was the Swiss Army knife of brains, able to cut through any subject with precision and style. Of course, Leonardo wasn't perfect. For all his brilliance, he had a habit of starting projects and never finishing them. Some of his most ambitious inventions stayed as sketches. Many of his paintings, including the Mona Lisa, were left unfinished or endlessly tinkered with. His notebooks are packed with half-developed ideas, brilliant but incomplete. But here's the thing, genius doesn't always mean finished products. Sometimes it means planting seeds that future generations will harvest. Leonardo's notebooks became time capsules of imagination, inspiring inventors, engineers, and artists centuries after his death. If Einstein's chalkboards showed equations, Leonardo's notebooks showed dreams. Both shaped the future, but in different ways. When people ask, was Leonardo da Vinci smarter than Einstein? The answer depends on how you define smart. Einstein gave us relativity, equations that bent the universe. Leonardo gave us a blueprint for being human at our most creative, connecting disciplines and imagining futures. Einstein specialized, Leonardo universalized. Einstein worked within the mathematical language of physics. Leonardo worked across languages, painting with oils, writing in mirrored script, carving in stone, and sketching machines powered by forces he couldn't fully explain but could somehow visualize. If genius is about range, Leonardo wins by a mile. And let's not forget the cultural impact. The Mona Lisa is a global icon, endlessly reproduced, parodied, and studied. The double helix may explain life, relativity may explain space and time, but Leonardo's smile explains humanity. Mysterious, layered, and timeless. At the same time, his futuristic sketches make him a legend in engineering and science. He left his mark not just on one field, but on art, medicine, mechanics, and imagination itself. That's a level of genius Einstein never reached, because Einstein was never expected to be universal. He was physics. Leonardo was everything. But Leonardo's genius also came with a sense of wonder. Reading his notebooks, you get the feeling of a man enchanted by the world. He wasn't trying to conquer nature or dominate it. He was trying to understand it, celebrate it, and imitate it. His flying machines were inspired by birds. His architectural ideas were shaped by the flow of rivers. His paintings captured the subtle shifts of human emotion. Genius isn't just about intelligence. It's about curiosity, empathy, and awe. Leonardo embodied all of that. His death in 1519 didn't dim his light. If anything, it made him larger than life. His works, both finished and unfinished, became symbols of Renaissance genius. His notebooks, rediscovered centuries later, revealed a mind so restless and imaginative that it feels modern even today. You can look at his sketch of a helicopter and think, Of course, that's obvious now, but it wasn't obvious then. That's what makes it genius, seeing what nobody else sees until centuries later. So if we're ranking the Einsteins of history, Leonardo da Vinci doesn't just make the list, he changes the scale. Einstein bent space and time, Leonardo bent reality itself, showing that a single human could paint, invent, dissect, and dream all at once. If genius means mastering one subject, Einstein is safe. But if it means being multi-talented, connecting worlds, and imagining futures so bold they feel alien, then Leonardo da Vinci makes Einstein look like a specialist, a one-trick genius compared to a man who was a dozen geniuses rolled into one. The Renaissance brain didn't just change art or science, it changed the way humans think about possibility. And maybe that's the ultimate definition of genius, not just solving problems, but showing us how big the world could be. If most geniuses are remembered for what they discovered, Richard Feynman is remembered just as much for how he explained it. He was a Nobel Prize winning physicist, a pioneer in quantum electrodynamics, a teacher who turned the most brain-melting concepts into everyday stories, and a prankster who never seemed to take himself too seriously. In a world where scientific brilliance often hides behind dense papers and chalkboard scribbles, Feynman had a gift that made him different. He could take the weirdness of the quantum world and make you feel like you understood it, even if only for a moment. If Einstein was the cosmic thinker, Feynman was the great explainer, and that ability to teach complex ideas simply was its own kind of genius. Born in 1918 in Queens, New York, Feynman didn't come from privilege or tradition. His father was a uniform salesman with a deep love for teaching his son how to ask questions. Instead of bedtime stories about princes and dragons, young Richard heard tales of the stars, atoms, and the mysteries of nature. That early encouragement to wonder about the world shaped him forever. He tinkered with radios, built contraptions, and taught himself math so quickly that by his teens he was devouring advanced calculus. By the time he entered MIT and later Princeton, it was clear this wasn't just another bright kid. This was a brain that worked like a magician's hat. No matter how often you reached inside, something surprising came out. Feynman's major contributions to physics were in the field of quantum electrodynamics, or QED, the theory that explains how light and matter interact. It's one of the most precise and successful theories in all of science, predicting experimental results down to an absurd number of decimal places. While many physicists approached it with abstract, impenetrable math, Feynman brought creativity to the table. He invented Feynman diagrams, those now famous little squiggles and arrows that physicists use to visualize interactions between particles. Instead of drowning in equations, you could draw a picture of electrons exchanging photons, and the math would follow. It was revolutionary, not just in accuracy, but in clarity. That clarity earned him the Nobel Prize in 1965, shared with Julian Schwinger and Shinichiro Tominaga. But here's the thing, even without the Nobel, he'd still be famous. Because Feynman's true genius wasn't just in solving physics problems, it was in making the rest of us care about them. While many scientists buried themselves in their ivory towers, Feynman came alive in front of a classroom. His lectures at Caltech became legendary. Students packed the halls not just because he was brilliant, but because he was entertaining. He spoke with energy, humor, and a knack for analogies. Instead of rattling off equations, he'd explain quantum mechanics by comparing it to something simple, like a game of checkers, or the way people walk down the street. His Feynman lectures on physics, published in the 1960s, are still used today, not just as textbooks, but as reminders that physics can be beautiful, elegant, and even fun. Many students have said they first fell in love with science because of those lectures. That's a level of influence equations alone rarely achieve. Feynman's genius for communication extended far beyond classrooms. He wrote books like Surely You're Joking, Mr. Feynman, and What Do You Care What Other People Think? That blended science with storytelling, humor, and a dash of mischief. He told stories of safe-cracking at Los Alamos, sketching nudes in topless bars, playing the bongos late into the night, and dismantling the pomp of academia with a laugh. He didn't just humanize science. He made scientists look like people you'd actually want to hang out with. For a public often intimidated by equations and jargon, Feynman was a breath of fresh air. He showed that curiosity could be playful, that learning could be joyful, and that even Nobel laureates could laugh at themselves. Of course, his time at Los Alamos during the Manhattan Project complicates the story. Feynman worked on the atomic bomb, a weapon of unimaginable destruction. He was young, enthusiastic, and swept up in the urgency of World War II. Later, he struggled with what it meant to have contributed to such devastation. But even there, his role reveals his genius. He solved practical problems, spotted errors, and contributed insights that sped up the project. And after the war, he shifted his focus to teaching and research that helped humanity rather than harm it. Genius often walks hand in hand with moral complexity, and Feynman was no exception. One of the moments that cemented Feynman's reputation as the great explainer came decades later, during the investigation of the Space Shuttle Challenger disaster in 1986. As a member of the Rogers Commission, Feynman cut through bureaucratic nonsense and technical jargon to show the public what had gone wrong. In a televised hearing, he dunked a piece of the shuttle's O-ring into a glass of ice water, demonstrating how cold temperatures made the material brittle. That simple demonstration, clear enough for anyone to understand, revealed the cause of the disaster better than pages of reports. It was pure Feynman. Strip away the fluff, show the truth, and do it in a way that makes sense to everyone watching. What made Feynman's genius so different from Einstein's or Newton's was the style. Newton was the brooding loner, Einstein the cosmic thinker. Feynman was the joker, the storyteller, the teacher who turned science into performance art. But beneath the jokes and antics was a razor-sharp mind that saw patterns others missed. He didn't just know the answers, he knew how to guide you to them so they felt like your own discoveries. That's rare. Explaining complicated ideas in a way that feels simple without being wrong is one of the hardest skills in the world. Feynman had it in spades. His approach to learning itself was revolutionary. He developed what's now called the Feynman technique, a method for mastering any concept by trying to explain it in the simplest terms possible. If you can't explain something to a freshman, he argued, you don't really understand it yourself. This philosophy pushed him to dig deeper into his own work and made his teaching legendary. Today, people use the Feynman technique not just in science, but in business, education, and personal growth. He wasn't just a physicist, he was a lifelong learner who taught others how to learn better too. Despite all this, Feynman wasn't perfect. He could be arrogant, dismissive, and even controversial in his attitudes, especially toward women. His personal stories sometimes reveal a casual sexism that hasn't aged well. But genius doesn't mean flawless, and ignoring his flaws would be dishonest. What matters is that alongside those flaws, he left behind a legacy of insight, teaching, and inspiration that continues to ripple outward. He made physics approachable, he made curiosity contagious, and he showed that intelligence doesn't have to be wrapped in solemnity. It can be joyful, mischievous, and human. So was Richard Feynman smarter than Einstein? Maybe not in the same way. Einstein bent the fabric of space-time. Feynman bent the barriers between science and the public. Einstein gave us relativity. Feynman gave us understanding. And in some ways, that's just as important. Because knowledge locked away in ivory towers changes little. Knowledge shared, explained, and made exciting. That transforms generations. Feynman's genius was the genius of translation, turning the incomprehensible into the unforgettable. His death in 1988 closed the chapter on one of science's most colourful characters, but his influence hasn't dimmed. His lectures are still studied, his books are still read, his diagrams are still drawn on whiteboards in physics departments worldwide, and his style, funny, clear, unpretentious, is still the gold standard for science communication. The great explainer may be gone, but his voice still echoes. What I cannot create, I do not understand. Richard Feynman showed us that genius isn't always about towering equations or solitary breakthroughs. Sometimes it's about lighting the path so others can walk with you. That's why he belongs in any discussion of the greatest minds, right alongside Einstein, Newton, Curie, and the rest. Not because he discovered everything, but because he made discovery accessible to everyone. And if that isn't a kind of brilliance bordering on magic, then what is? If genius means bending the laws of the universe, Einstein gets his due. But if genius means changing the course of history while laying the groundwork for the digital age we live in, Alan Turing might just be in a category of his own. He was the father of computer science, the man who cracked the Enigma code during World War II, and the thinker who imagined machines that could reason long before the word computer meant anything more than a person with a pencil. Turing didn't just solve equations, he saved millions of lives, shortened a world war, and set humanity on the path to smartphones, laptops, and artificial intelligence. That's not just smart. That's civilization-shaping brilliance. Born in London in 1912, Turing showed signs of being different from the start. As a child, he was intensely curious, fascinated by numbers, puzzles, and science experiments. He wasn't the polished, socially graceful prodigy that some people expect. He was awkward, shy, eccentric. But his brain lit up in ways that made up for any lack of polish. By the time he reached Cambridge University, he was already thinking about problems so abstract that most people wouldn't even know how to phrase them. His 1936 paper, On Computable Numbers, introduced the concept of what we now call the Turing machine, a simple abstract model that could simulate the logic of any algorithm. At the time, it probably looked like an obscure piece of math. In reality, it was the blueprint for modern computing. Every laptop, phone, and AI today owes its lineage to that single idea. Think about how radical that was. In the 1930s, computers were humans with pencils and paper, hired to do calculations by hand. The idea of building a machine that could follow a sequence of instructions and solve problems in general, that was science fiction. Yet Turing imagined it, described it, and proved mathematically what such a machine could and couldn't do. The concept of the Turing machine is still used today as the theoretical foundation of computer science. Before anyone built a computer, Turing invented the idea of computability itself. That's like drawing up a map of the internet in 1936, before the first transistor even existed. But Turing's genius wasn't just theoretical, it turned practical and world-changing during World War II. The German military used the Enigma machine to encrypt their communications, a device that created seemingly unbreakable codes by scrambling letters through a series of rotors. The Allies could intercept the messages, but without breaking the code, they were gibberish. The stakes couldn't have been higher. Cracked messages meant knowing where U-boats were lurking in the Atlantic, saving convoys from destruction and anticipating troop movements that could decide battles. Failure meant chaos, starvation, and possibly losing the war. Enter Alan Turing. At Bletchley Park, the secret British code-breaking centre, Turing designed electromechanical machines known as bombs that could test possible Enigma settings at lightning speed compared to humans. He streamlined the process, cutting through the astronomical number of possible combinations. With his techniques, the Allies were able to read vast amounts of German military communications. Historians estimate that Turing's work shortened the war by 2 to 4 years and saved millions of lives. Think about that. Millions. If intelligence is measured by impact, that's about as big as it gets. Einstein bent space-time, but Turing bent history itself. And yet, Turing didn't stop there. His wartime work launched him deeper into the emerging world of digital computing. After the war, he worked on building actual early computers, helping to transform the theoretical into reality. He also turned his mind toward artificial intelligence, asking whether machines could think. His famous Turing test, proposed in 1950, asked whether a machine could imitate human responses well enough to fool an interrogator. It's still discussed today as a benchmark for AI. Imagine being so far ahead that your philosophical thought experiments still guide technology 70 years later. Turing wasn't just dreaming about the future, he was living in it while the rest of the world caught up. But as with so many geniuses, his story has a tragic side. Despite his heroic contributions to the war, Turing's life was marred by prejudice and injustice. He was openly homosexual in a time when homosexuality was illegal in Britain. In 1952, he was prosecuted for gross indecency and given the choice between prison and chemical castration. He chose the latter, endured humiliating treatment, and continued his work, but the toll was immense. In 1954, at the age of just 41, Turing died from cyanide poisoning, likely by suicide, though some argue it might have been accidental. The world lost one of its greatest minds far too soon, not because of natural limits, but because society failed him. For decades, his role in the war was classified, his reputation overshadowed, his genius hidden. Watson and Crick became famous for DNA. Einstein's face was plastered everywhere. Turing remained in the shadows. It wasn't until long after his death that his contributions were declassified and recognized. Today, statues honor him, books celebrate him, and even a blockbuster movie, The Imitation Game, has helped share his story. In 2013, Queen Elizabeth II granted him a posthumous royal pardon. In 2021, his face appeared on the £50 banknote, a symbolic but overdue recognition of his role as one of the greatest minds of all time. So what makes Turing's genius so remarkable? It's the range. He wasn't just a code breaker. He wasn't just a mathematician. He wasn't just a computer scientist. He was all of them at once. He saw the abstract logic of computation, applied it to the real-world urgency of war, and then extended it into visions of artificial intelligence. He solved puzzles on every scale, from the letters of encrypted messages to the philosophical question of whether machines could be conscious. And he did it with a humility and quiet focus that belied the enormity of his impact. Was Alan Turing smarter than Einstein? Again, it depends on how you measure. Einstein gave us the equations of the cosmos. Turing gave us the tools to build the digital future. Without Turing, we might not have computers as we know them, and we might not even be here in the same way, because the war could have gone very differently. In terms of practical impact, saving lives and inventing entire industries, Turing's genius stands shoulder to shoulder with anyone. His story also reminds us that genius is fragile. It needs nurturing, protection, and recognition. Turing had all the brains in the world, but society punished him instead of celebrating him. Imagine what else he could have achieved if he had lived another 30 or 40 years, working on AI, computing, and maybe even biology. Maybe we'd be even further ahead today. The injustice of his life isn't just personal. It's a loss to humanity. And yet, despite that injustice, his legacy shines brighter than ever. Every smartphone, every laptop, every AI chatbot, every digital network traces back to his ideas. Every time a code gets cracked, every time a machine does something intelligent, it echoes Turing's vision. He didn't just imagine the future, he built the foundations of it with equations, wires, and the sheer force of genius. So the next time someone talks about Einstein as the ultimate symbol of intelligence, remember Alan Turing, the quiet codebreaker who outsmarted the Nazis, invented computer science, dreamed of AI, and left behind a legacy that powers the modern world. If genius is measured by saving lives, shaping technology, and daring to ask questions no one else even thought to ask, then Alan Turing wasn't just smart, he was extraordinary. He was, and always will be, the codebreaker who cracked history and rewired the future. When you picture ancient Alexandria, you probably think of scrolls, libraries, marble statues, and maybe the occasional philosopher in a toga rambling about the meaning of life. What you might not picture is one of the greatest intellectuals of her age, a woman who became a mathematician, philosopher, and astronomer centuries ahead of her time. Her name was Hypatia, and her story proves something we sometimes forget. Genius isn't modern. It didn't start with Einstein's messy hair or Newton's apple. It has existed for thousands of years, popping up in places where curiosity burned brighter than prejudice, even if the world wasn't ready to accept it. Hypatia was born around 355 CE in Alexandria, Egypt, a city famous for its learning. This was the home of the legendary Library of Alexandria, the kind of place nerds would have called heaven, a vast collection of scrolls, knowledge, and scholars. Hypatia grew up surrounded by this culture of learning, and her father, Theon, was himself a mathematician and astronomer. He wasn't just a parent who gave her bedtime stories. He gave her access to one of the greatest intellectual toolkits of the ancient world. Instead of dolls and fairy tales, she got geometry, astronomy, and philosophy. That early start turned her into one of history's rarest figures, a woman who not only studied the sciences in a world dominated by men, but rose to become one of its leading lights. Her brilliance was wide-ranging. She taught mathematics, explaining the works of Euclid and Diophantus. She lectured on astronomy, guiding students through the movement of the planets and the mysteries of the cosmos. She was also a philosopher in the Neoplatonic tradition, blending logic, metaphysics, and ethics into teachings that attracted students from across the Mediterranean. Imagine walking into her classroom. There's Hypatia in robes, chalk, or its ancient equivalent, in hand, talking about equations, then pivoting to the stars, then pivoting again to the big questions of existence. She wasn't just a specialist, she was a Renaissance brain 1,000 years before the Renaissance. Hypatia is credited with improving instruments like the astrolabe, a device used to measure the positions of stars and planets. She helped refine the hydrometer, which measured the density of liquids. Her work in mathematics included commentaries on important texts, preserving and clarifying knowledge that might otherwise have been lost. In an era when much of science was fragile, easily destroyed by fire, politics, or neglect, her writings acted like a bridge carrying knowledge forward. Without people like her, some of the most important ideas of antiquity might never have survived to inspire later generations. But what made Hypatia truly extraordinary wasn't just her technical skill. It was her presence. Picture a society where women were mostly confined to domestic roles, rarely seen in the public sphere of science or philosophy. Then imagine Hypatia striding through Alexandria, openly teaching male students, advising political leaders, and being consulted on matters of astronomy and philosophy. She wasn't tucked away in private rooms, she was center stage. That level of visibility was revolutionary. She embodied the idea that genius doesn't come with a gender, centuries before anyone would even phrase it that way. Her popularity was immense. Students flocked to her lectures. Governors and scholars sought her advice. She became a symbol of wisdom and learning. And with that fame came danger. Alexandria at the time was a volatile place, torn by political and religious tensions. Hypatia, as a philosopher and scientist, represented rational inquiry in an age when dogma and conflict were rising. In 415 CE, during a period of violent strife between Christians and pagans in the city, she became a target. A mob, spurred by political enemies and religious extremists, brutally murdered her. Her death was shocking, not just because of its violence, but because it symbolized the clash between free inquiry and fanaticism, an ancient genius silenced by intolerance. For centuries, her story was distorted, forgotten, or reduced to myth. Some painted her as a martyr for science, others as a pagan symbol crushed by Christianity. The truth is both simpler and more powerful. Hypatia was a brilliant scientist, philosopher, and teacher, whose very existence challenged the boundaries of her society. Her murder was a tragedy, but her legacy endured, whispered through the writings of her students and preserved in the commentaries she left behind. She became a symbol of intellectual courage, the reminder that truth-seeking often comes at a cost. Now, let's play the Einstein comparison game. Was Hypatia smarter than Einstein? Obviously, they lived in different universes of knowledge. Einstein gave us relativity. Hypatia worked with geometry, astronomy, and philosophy at a time when the very idea of scientific method was still developing. But here's what makes her shine in this lineup of history's geniuses. She was centuries ahead of her time. She proved that brilliance isn't bound by era, culture, or gender. She was explaining the cosmos and refining instruments in the 5th century, while the rest of the world was barely holding on to the scraps of Greek philosophy. She wasn't standing on the shoulders of giants, she was one of the giants, holding up knowledge so future generations could climb. Her genius also forces us to rethink what intelligence means. It's not always about making brand new discoveries. Sometimes it's about preserving knowledge when the world wants to forget it. Sometimes it's about teaching, inspiring, and making sure the torch of reason doesn't go out in the chaos of politics and war. Hypatia did all of that. She was a living bridge between the classical world and the future, keeping alive the kind of thinking that would one day make the Renaissance possible. Without her, who knows what might have been lost? Hypatia's story resonates today because it reminds us that women have always been part of science and philosophy, even if their names were erased from the record. For every Einstein celebrated in the open, there were countless Hypatias working in the shadows, their brilliance ignored or punished. Rediscovering her isn't just about filling a gap in history, it's about acknowledging that genius is universal and always has been. The irony is that Einstein, Newton, and other male geniuses had their struggles, but they were at least recognized in their lifetimes. Hypatia was celebrated in hers, but condemned to a violent end, her name smeared by those who feared her influence. And yet, centuries later, she's remembered as one of the first great female scientists, her legend stronger than the politics that tried to erase her. That resilience, the way her memory outlasted her killers, is its own form of brilliance. So was Hypatia of Alexandria one of the smartest people who ever lived? Absolutely. She might not have written Relativity, but she embodied the very spirit of inquiry that makes relativity possible. She showed that genius isn't bound by time, place, or circumstance, and she proved that brilliance, even when silenced, can echo across centuries. The next time you think of ancient history as dusty ruins and forgotten scrolls, remember Hypatia, the mathematician who calculated, the astronomer who gazed at the stars, the philosopher who asked the big questions, and the teacher who passed on knowledge in a world trying to destroy it. Genius didn't start in the modern age. It's been with us all along, blazing like a candle in the dark. And Hypatia's candle still burns. If genius had a face in the modern age, for many people it was Stephen Hawking, the man in the wheelchair, speaking through a voice synthesizer who seemed to hold the entire universe in his mind. He wasn't just a physicist who revolutionized our understanding of black holes and cosmology. He was a symbol of intellect and resilience, a reminder that even when the body fails, the human mind can soar higher than galaxies. Hawking turned scientific equations into cultural touchstones, and his very life story became proof that genius isn't just about what you discover, but about the sheer will to keep discovering when everything is stacked against you. Born in 1942 in Oxford, England, Stephen Hawking didn't exactly look like a future Einstein in his early years. By his own admission, he was lazy in school, curious, but not particularly focused. Teachers saw potential, but he wasn't the kid racking up perfect grades. He liked tinkering, building model airplanes and boats, more interested in how things worked than in rote memorization. But as he grew older, it became clear that his mind had a spark, especially when it came to mathematics and physics. He studied at Oxford, then Cambridge, diving into the mysteries of the universe at the precise moment when cosmology, the study of the universe's origins and structure, was heating up. Then tragedy struck. At just 21 years old, while still a student, Hawking was diagnosed with amyotrophic lateral sclerosis, ALS, also known as Lou Gehrig's disease. Doctors told him he had maybe 2 years to live. Imagine that. You're just starting your career, and you're told the clock is already running out. For most people, that would be the end. But Hawking? He decided to keep going, because curiosity, it turned out, was stronger than fear. He married, continued his studies, and dove headfirst into research. The disease gradually took away his ability to walk, to write, to speak. But it never touched the part of him that mattered most, his mind. Hawking's scientific genius was centered on black holes, those cosmic monsters where gravity is so strong that not even light can escape. Before him, black holes were mostly theoretical curiosities, scary mathematical predictions with little known about them. Hawking asked the right questions. What happens at the boundary of a black hole, the event horizon? Does information disappear forever when it falls in? Does the black hole last forever, or can it shrink and vanish? In the 1970s, he proposed something astonishing. Black holes aren't completely black. They emit radiation due to quantum effects near the event horizon. This radiation, now called Hawking radiation, means black holes can slowly evaporate over time, eventually disappearing. It was a groundbreaking insight, merging quantum mechanics, relativity, and thermodynamics, 3 fields that usually don't play well together. The idea stunned physicists and reshaped the way we think about the universe. This wasn't just another abstract paper. Hawking radiation forced scientists to grapple with deep paradoxes, like whether information is truly lost when it falls into a black hole. That information paradox is still one of the hottest debates in physics, fueling research into string theory, quantum gravity, and the ultimate nature of reality. Hawking didn't just solve problems. He created entirely new frontiers for others to explore. If Einstein gave us relativity, Hawking gave us the mystery of what happens when relativity and quantum mechanics collide. That's not just smart, that's visionary. Beyond black holes, Hawking contributed to our understanding of the Big Bang, singularities, and the ultimate fate of the cosmos. He showed that the universe had a beginning, a singularity where all laws of physics break down, and that black holes, far from being cosmic oddities, are central to understanding space and time. He wasn't afraid to ask the biggest, boldest questions. Where did the universe come from? Why is there something rather than nothing? Could the laws of physics allow multiple universes? He made cosmology not just a niche field, but a subject ordinary people wanted to talk about over dinner. And that's where his genius really became cultural. Hawking wasn't just a physicist working in isolation. He became a public figure, a science celebrity. His 1988 book, A Brief History of Time, became a global bestseller, selling millions of copies. Think about that. A book about cosmology, black holes, and the nature of time, not exactly light reading, became something people bought for their coffee tables, their kids, their friends. Even if most readers didn't make it past chapter 3, it didn't matter. The book sparked curiosity. It made science feel epic, mysterious, and worth exploring. It turned Hawking into the Einstein of his age, not just for his theories, but for his ability to capture imaginations. Part of Hawking's cultural impact came from his unique presence. The wheelchair, the voice synthesizer, the fact that he defied a terminal diagnosis for decades, it all made him a symbol of resilience. He became proof that genius isn't stopped by physical limits. He gave lectures, wrote papers, appeared in documentaries, and even guest starred on The Simpsons and Star Trek, The Next Generation. His voice became iconic, instantly recognizable, not because it was natural, but because it was artificial, mechanical, and yet deeply human. He didn't shy away from humor either, often poking fun at himself, making jokes about black holes or technology, reminding the world that behind the machine was a sharp wit. Was Hawking smarter than Einstein? Again, it depends on the metric. Einstein gave us relativity, the cosmic foundation of modern physics. Hawking expanded that foundation into the unknown, merging relativity with quantum theory in ways Einstein never could. Einstein didn't believe in black holes at first, dismissing them as mathematical quirks. Hawking made them central to physics. If you measure genius by persistence, by working through immense physical challenges while still producing groundbreaking science, Hawking might take the crown. Where Einstein worked with chalk in comfort, Hawking typed equations painstakingly with a single cheek muscle, proving that the mind doesn't bow to the body. Hawking's personal life also added to his legend. He married, divorced, remarried, raised children, and lived a life filled with both triumph and struggle. He faced immense challenges, physical decline, reliance on caregivers, controversies around his personal relationships. But through it all, he never stopped thinking, writing, or pushing the boundaries of science. His life wasn't perfect, but it was profoundly human, and that humanity made his genius relatable in a way pure equations never could. When he died in 2018 at the age of 76, the world mourned not just a scientist, but a cultural icon. Bells tolled in Cambridge. Tributes poured in from presidents, scientists, actors, and ordinary people who had been inspired by his story. His ashes were buried in Westminster Abbey, near the graves of Newton and Darwin, a fitting place alongside the other giants of science. In many ways, his life had come full circle, joining the pantheon of the greatest minds in history. So what does Stephen Hawking's genius really teach us? That brilliance isn't just about the discoveries, it's about the resilience to keep asking questions, even when the world tells you that you shouldn't still be alive. It's about the ability to take abstract equations and turn them into cultural conversation. It's about showing that even in a broken body, the human spirit can stretch across galaxies. Hawking was a cosmic visionary, not because he solved everything, but because he dared to ask everything. The next time you see an image of a black hole, or read about the Big Bang, or watch a documentary that makes you feel small and infinite all at once, remember Stephen Hawking. He didn't just study the universe. He embodied the resilience and curiosity that make us part of it. Einstein bent space-time. Hawking peered into the abyss and told us what might be there. That's not just genius, that's courage, written in the language of the cosmos. If intelligence were just about solving equations, Galileo Galilei would already be near the top of the list. But what makes him stand out in the history of genius isn't only what he discovered. It's the fact that he discovered it while staring down the most powerful institution of his time. This was a man who looked up at the heavens, saw moons circling Jupiter, and dared to say, "Hey, maybe Earth isn't the center of everything after all." That kind of statement didn't just take brains, it took courage. Galileo wasn't just smart, he was rebellious smart, the kind of genius who changes the rules of the game and gets punished for it, only to be vindicated centuries later. Born in Pisa in 1564, Galileo started out like a lot of great thinkers, curious, restless, and a little bit of a troublemaker. He was supposed to study medicine at the University of Pisa, but instead of memorizing anatomy, he found himself fascinated by math and physics. He would watch chandeliers swinging in cathedrals and notice the regularity of their motion, planting the seeds of his later work on pendulums. He wasn't impressed by the dry lectures of the day. He wanted to test things, measure them, and find patterns. In a time when many scholars were still reciting Aristotle's ideas like gospel, Galileo was the guy whispering, "But what if Aristotle was wrong?" That whisper would eventually become a roar. One of his most famous early experiments was dropping balls of different weights from the Leaning Tower of Pisa. According to Aristotle, heavier objects should fall faster than lighter ones. Galileo put that to the test and found, nope, they fall at the same rate when air resistance doesn't interfere. He didn't just accept authority, he tested it. That approach, simple as it sounds, is what makes him the father of modern science. He insisted that knowledge should come from observation and experiment, not from ancient texts or decrees. That shift alone changed the course of human thought. Then came the telescope. Galileo didn't invent it, but when he heard about a new Dutch gadget that made faraway objects look closer, he immediately built his own, refining the design to make it stronger. In 1609, he pointed it at the night sky, and the universe opened up. He saw craters and mountains on the moon, shattering the belief that celestial bodies were perfect and unblemished. He saw countless stars invisible to the naked eye, proving the cosmos was far richer than anyone imagined. He saw the 4 largest moons of Jupiter, now called the Galilean moons, orbiting around the planet, a clear sign that not everything revolved around Earth. He even observed the phases of Venus, which made sense only if Venus orbited the Sun, not Earth. These discoveries weren't just observations, they were smoking guns against the geocentric model of the universe. At the time, the dominant worldview was that Earth sat at the center, with everything else orbiting around it. This wasn't just science, it was theology, backed by the Catholic Church. To say otherwise wasn't just wrong, it was dangerous. But Galileo, armed with his telescope and his curiosity, couldn't ignore the evidence. He began championing the heliocentric model proposed by Copernicus, arguing that the Sun, not Earth, was the center of the solar system. He didn't just write technical papers, he published Dialogue Concerning the Two Chief World Systems, a book written like a conversation between characters debating geocentrism versus heliocentrism. The character supporting geocentrism was portrayed as foolish, often echoing the Pope's own arguments. You can probably guess how that went over. The Church was not amused. Galileo was hauled before the Inquisition in 1633, accused of heresy, and forced to recant his support of heliocentrism. Legend says he muttered under his breath, "Eppur si muove," and yet it moves, meaning that no matter what the Church declared, Earth still orbited the Sun. Whether he actually said it or not, the phrase captures the essence of Galileo's genius. Truth doesn't bow to authority. He was sentenced to house arrest, spending the last years of his life confined. But even then, he kept writing, studying motion, mechanics, and the nature of the universe. His discoveries went far beyond astronomy. He studied motion and laid the groundwork for Newton's laws. He explored inertia, acceleration, and projectile motion, showing that mathematics could describe how objects move on Earth as well as in the heavens. He invented the thermoscope, a precursor to the thermometer, and improved tools for measuring time. He was obsessed with precision, measurement, and the belief that the universe was written in the language of mathematics. Philosophy is written in that great book which is ever open before our eyes. I mean the universe, he once wrote. But we cannot understand it if we do not first learn the language. That language is mathematics. For Galileo, math wasn't just abstract symbols. It was the key to reality itself. Was Galileo smarter than Einstein? Well, Einstein himself admired him, calling him the father of modern physics. Einstein had the luxury of working in a world where scientific method was already established. Galileo was inventing that method in a world where questioning Aristotle could get you into serious trouble. If genius is measured not only by what you discover, but by the risks you take to defend it, Galileo's courage adds weight to his intelligence. He wasn't just thinking outside the box. He was willing to be punished for it, because he believed the truth mattered more than comfort. The tragedy of Galileo's story is that he suffered for his ideas in his own lifetime, only to be celebrated centuries later. The church officially cleared him of wrongdoing in 1992. That's nearly 400 years after his trial. But the delay doesn't erase the fact that he won. Today, every student learns that Earth orbits the Sun. Every telescope pointed at the night sky is an echo of Galileo's first peak. Every rocket that leaves our planet owes something to the man who dared to say Earth wasn't the center of everything. Galileo's genius wasn't just in observation or math. It was in blending them with storytelling. His dialogue wasn't a dry paper. It was written to be read, debated, and understood by more than just scholars. He knew that to change minds, you had to make the truth accessible. That same spirit echoes in modern science communicators like Carl Sagan, Neil deGrasse Tyson, and Richard Feynman. Galileo was one of the first to realize that explaining the universe was just as important as discovering it. And maybe that's why his story still resonates. He reminds us that intelligence without courage is fragile, but intelligence with courage changes history. He wasn't just mapping the heavens, he was showing humanity how to think differently, how to trust observation over dogma, how to insist that truth is bigger than tradition. That combination of brains and bravery is what makes him the rebel genius. The next time you look up at the night sky, remember Galileo. Remember the man who saw craters on the moon, moons around Jupiter, and phases of Venus, and who had the audacity to say what he saw, even when it cost him his freedom. Einstein bent space-time, but Galileo bent the entire trajectory of how we do science. And that, in the long arc of history, is genius of the highest order. When you think of the moon landing, you probably picture rockets roaring, astronauts bouncing in low gravity, and maybe Neil Armstrong dropping that famous line about one small step. What you might not picture is Katherine Johnson, a quiet mathematical genius sitting at a desk in Virginia, pencil in hand, calculating trajectories that made the whole thing possible. Without her math, John Glenn might not have orbited Earth safely, and Apollo astronauts might not have come home. Johnson wasn't on the rocket, but her brain was. In fact, her math literally reached the moon. That's not just intelligence, that's hidden brilliance that changed the course of history. Katherine Johnson was born in 1918 in White Sulphur Springs, West Virginia, and from the start, numbers seemed to flow through her veins. By the age of 10, she was already in high school. Imagine being barely tall enough to see over the desk and already solving equations that made adults scratch their heads. She was obsessed with counting everything: steps, stars, anything measurable. Her family encouraged her talent, sending her to a special school for African American students who could handle advanced math. By the age of 18, she had graduated college with degrees in mathematics and French. And here's the kicker. She was so good that professors bent rules just to let her into advanced courses because they couldn't deny her brilliance. In the 1950s, Johnson joined what was then NACA, the National Advisory Committee for Aeronautics, which later became NASA. At the time, women working in math and science were often referred to as computers, human calculators who crunched numbers before electronic computers were widespread. Johnson was part of a segregated group of African American women mathematicians at Langley Research Center. They were tucked away in a separate office labeled Colored Computers, a stark reminder of the racism and sexism of the era. But Johnson's skill soon broke through the barriers. Her reputation spread quickly. If you had a tough calculation, Katherine Johnson was the person you wanted. Her work covered trajectory analysis, orbital mechanics, and re-entry calculations, the kind of math where the slightest mistake could mean disaster. In 1962, when John Glenn prepared to become the first American to orbit Earth, he was uneasy about relying on the new electronic computers to check the flight path. Computers could glitch, they could fail. Glenn famously said, "Get the girl to check the numbers." That girl was Katherine Johnson. She reviewed the orbital equations by hand, confirming the computer's output. Glenn trusted her math more than he trusted the machine. He refused to launch until she gave the green light. That flight succeeded, a key Cold War victory for the United States, and Katherine Johnson's name was quietly etched into space history. And then came Apollo. Johnson's calculations for the trajectory of Apollo 11 helped send astronauts to the moon and bring them back. She figured out the precise timing of launch windows, the math for re-entry angles, the paths that would allow spacecraft to slingshot around the moon's gravity. If you've ever thrown something in the air and watched it arc back down, Imagine doing that with a spaceship and making sure it doesn't burn up in the atmosphere or miss Earth entirely. That was Johnson's job. Failure wasn't an option. She turned celestial mechanics into survival plans. When Neil Armstrong set foot on the moon, Katherine Johnson's math was right there under his boots. Her genius wasn't just about equations, it was about persistence. She worked in a world where women were often dismissed, and black women doubly so. She fought her way into meetings where women weren't normally allowed. She raised her hand, asked questions, and insisted on being heard. She once said, "I didn't feel the boundaries. I just knew I had to do the job, and I was going to do it." That attitude is genius in its own right, the ability to ignore the noise, focus on the problem, and push through barriers. Her story remained largely hidden for decades, overshadowed by astronauts and engineers. But in 2016, the book and film Hidden Figures brought her and her colleagues, Mary Jackson and Dorothy Vaughan, into the spotlight. Suddenly, the world realized the Apollo program didn't just rest on rockets and astronauts. It rested on the brains of brilliant women who had been erased from the headlines. Katherine Johnson lived long enough to see that recognition. She received the Presidential Medal of Freedom in 2015 from President Barack Obama, who called her a pioneer who broke barriers of race and gender. She even got to witness her name on buildings and schools, ensuring future generations wouldn't forget. So was Katherine Johnson smarter than Einstein? Einstein reshaped the laws of physics with relativity. Johnson reshaped reality with math that made rockets fly true and astronauts come home alive. Einstein lived in theory, Johnson lived in precision. Einstein asked, "What if light bends space?" Johnson asked, "What angle should Apollo hit the atmosphere so it doesn't skip off into space like a rock on water?" Both were geniuses, but Johnson's genius carried an added weight. She was solving life-or-death problems under immense pressure, in an environment that wasn't built to recognize her brilliance, and she nailed it, every time. Her story also shows that genius isn't just about brains. It's about courage. It's about stepping into rooms where you're not welcome and proving you belong. It's about carrying the burden of being the only one, knowing mistakes would be blamed on your gender or race, but showing up anyway. Katherine Johnson's math was flawless, but her courage was just as vital. Because without both, America might not have reached the stars when it did. When Johnson passed away in 2020 at the age of 101, tributes poured in from NASA, astronauts, presidents, and students. The headlines called her a hidden figure, but by then she was hidden no longer. She had become a symbol, not just of NASA's success, but of what happens when brilliance refuses to be ignored. Her life proves that genius doesn't always come with messy hair or loud equations. Sometimes it comes with quiet determination, sharpened pencils, and the courage to say, "Let me check those numbers." Every time we look at the moon today, we should remember Katherine Johnson. Her math reached it before we ever did. Her calculations carved the path between Earth and space, turning what looked like an impossible dream into a precise trajectory. And her story carved another path, one for women, for black women, for anyone told they don't belong in science. She proved them wrong, one equation at a time. So if we're making a Hall of Fame of geniuses, Einstein might be the poster child, but Katherine Johnson is the hidden brain who deserves a permanent spotlight, because while Einstein bent space-time, she bent history, sending humanity to the moon and bringing it safely back, all with the power of her mind. That's not just genius, that's legacy. If you want proof that Einstein wasn't the final word on genius, just look at who Einstein himself bowed to. Emmy Noether. That's right. The same Einstein who gave us relativity, bent space-time, and became the global icon of brains, once admitted that Emmy Noether was a greater mathematical genius than he was. Her theorems underpin modern physics, her work revolutionized abstract algebra, and her career was a battle against sexism that would have crushed anyone less determined. If genius is defined by changing the rules of the game, Emmy Noether didn't just play the game. She rewrote it so thoroughly that today's scientists are still living in her world. Emmy Noether was born in 1882 in Erlangen, Germany, into a family that already had mathematics in its blood. Her father was a math professor, so she grew up surrounded by numbers and equations. But being born a woman in the 19th century meant the deck was stacked against her from the beginning. Universities didn't want women in advanced programs. Professors often dismissed them as curiosities. But Emmy had the kind of determination that doesn't back down. She fought her way into lectures, sometimes only as an auditor, because women weren't officially allowed to enroll. She studied anyway. She earned her doctorate in mathematics in 1907, but even with a PhD, she wasn't offered a proper academic position. Instead, she taught for free under the names of male professors, doing the work while others got the credit. If that doesn't show persistence, nothing does. Her early work focused on abstract algebra, a branch of math that deals with structures and systems rather than just numbers. To most people, abstract algebra looks like pure brain-bending nonsense: rings, groups, fields, symmetries. But this was where Emmy thrived. She had a gift for spotting deep connections where others saw chaos. She streamlined concepts, generalized theories, and built frameworks that mathematicians still rely on today. In a world where math was becoming more abstract, more about the invisible skeleton of logic itself, Noether was the queen. Then came her most famous contribution, Noether's theorem, published in 1918. If you've never heard of it, don't feel bad. It's one of those results that hides in the background while quietly running the universe. Put simply, Noether's theorem links symmetries in physics to conservation laws. What does that mean? Well, if the laws of physics don't change over time, then energy is conserved. If the laws of physics don't change when you move in space, then momentum is conserved. If they don't change when you rotate, then angular momentum is conserved. Symmetry equals conservation. It's one of the most profound insights ever made in theoretical physics, a Rosetta Stone that unlocked how the universe keeps its books balanced. Einstein himself was blown away. At the time, he was wrestling with general relativity and the problem of conservation of energy in curved space-time. Noether stepped in and provided the clarity he needed. He later wrote that she was the most significant creative mathematical genius thus far produced since the higher education of women began. That's Einstein, the guy we literally use as a synonym for smart, saying Emmy Noether was the real deal. If you want to know who out-Einsteined Einstein, it was her. But her genius didn't stop there. Her work in algebra laid the foundations for much of modern mathematics. Concepts like Noetherian rings and modules sound terrifying, but they're the bedrock of algebraic geometry, topology, and theoretical physics. When you hear about string theory, quantum field theory, or the standard model of particle physics, you're hearing echoes of Noether. Her fingerprints are everywhere, even if most people don't know her name. Of course, being brilliant didn't mean her life was easy. She spent years fighting for recognition, often teaching under male colleagues' names or for little pay. In 1919, she finally got a teaching position at the University of Göttingen, but only after her supporters, including giants like David Hilbert, fought against opposition from faculty who thought a woman teaching would be inappropriate. One critic even asked, "What will our soldiers think when they return to the university and find they are expected to learn at the feet of a woman?" Hilbert famously snapped back, "I do not see that the sex of the candidate is an argument against her admission as a lecturer. After all, we are a university, not a bathhouse." Noether got the job and promptly went on to revolutionize mathematics. Her career in Germany was cut short when the Nazis came to power in 1933. As a Jewish woman, she was doubly vulnerable. She fled to the United States, where she taught at Bryn Mawr College, inspiring a new generation of women mathematicians. She continued her work there, lecturing at Princeton and writing until her death in 1935, at just 53 years old, after complications from surgery. Her life was far too short, but her impact was infinite. So was Emmy Noether smarter than Einstein? Again, it depends how you measure. Einstein had the charisma, the wild hair, and the theories that made headlines. Noether had the quiet, profound insights that reshaped the entire framework of math and physics. Einstein worked in visible revolutions, bending time and space. Noether worked in invisible revolutions, linking symmetries and conservation laws that underpin every law of physics we use today. Without her, modern physics would be unrecognizable, and Einstein himself admitted she outshone him in raw mathematical creativity. That's like Michael Jordan saying, "Actually, she's the better player." You don't ignore that kind of endorsement. Her legacy is only now getting the recognition it deserves. For decades, her name was buried under the weight of sexism and historical neglect. but mathematicians and physicists revere her as one of the greatest minds of all time. Buildings, conferences, and theorems bear her name. The more you dig into modern science, the more you realize that behind the famous men's equations stands Noether's framework, holding it all together. What makes her story especially powerful is the combination of brilliance and resilience. She didn't just solve problems. She solved them while fighting barriers that said she wasn't even supposed to be in the room. She didn't just create math. She created it in a world that often told her she couldn't, shouldn't, or wouldn't be taken seriously. That's not just intelligence. That's courage paired with genius. The next time someone rattles off Einstein, Newton, or Hawking as the greatest scientific minds, throw Emmy Noether into the mix. Remember the woman who gave physics its backbone, who made algebra into a universal language, and who left Einstein himself in awe. She was the queen of abstract math, and her reign continues every time physicists write down a conservation law or mathematicians open a textbook on algebra. So yes, Einstein bent space-time, but Emmy Noether bent the very rules of math and physics to reveal the hidden symmetries of the universe. And if that isn't a genius greater than Einstein, then what is? When most people hear the word genius, they picture Albert Einstein, the wild hair, the pipe, the twinkle in his eye as he scribbles equations about relativity. Einstein has become the cultural mascot of intelligence, the shorthand for "this person is ridiculously smart." But here's the thing. As brilliant as Einstein was, he wasn't the only flavor of genius out there. Brilliance comes in many forms: math, biology, technology, philosophy, art, and history is packed with people whose intellect was just as world-changing, just in different ways. Einstein was iconic, yes, but he wasn't unique. He was one dazzling star in a galaxy filled with minds that bent reality in their own directions. Think about it like ice cream. Einstein was chocolate, universally loved, instantly recognizable, a standard. But genius has more flavors than your average ice cream parlor. You've got Newton, the vanilla that's deceptively plain until you realize it underpins the entire sundae. You've got Leonardo da Vinci, the Neapolitan scoop who refuses to stick to one taste and gives you art, engineering, anatomy, and invention all at once. You've got Marie Curie, a radioactive swirl of brilliance who discovered elements and redefined chemistry. You've got Alan Turing, the sharp, futuristic mint chocolate chip who cracked Nazi codes and built the foundations of computing. Each one tastes different, but all are equally genius. Comparing them directly to Einstein is like asking whether Beethoven was smarter than Newton. Wrong category, same brilliance. Take mathematics. Einstein was no slouch, but even he admitted there were mathematicians who outclassed him. Srinivasa Ramanujan, for example, was producing formulas and theorems that still stump experts today, without formal training. Emmy Noether created the mathematical backbone of modern physics, her theorems linking symmetries to conservation laws so deeply that Einstein himself praised her as a genius greater than his own. Ramanujan and Noether show a flavor of brilliance that doesn't get posters on dorm walls, but quietly holds up the scaffolding of science itself. Without them, Einstein's relativity would wobble. Math geniuses aren't always in the spotlight, but their work is the skeleton under the skin of every theory. Now look at biology. Charles Darwin wasn't scribbling equations about light speed. He was wandering around islands, staring at finch beaks, and realizing he'd stumbled upon the secret engine of life, natural selection. His genius was in seeing the obvious that nobody else saw. Rosalind Franklin, with her X-ray crystallography, revealed the double helix of DNA, the code of life, even though she didn't get the credit she deserved in her time. Darwin and Franklin reshaped our understanding of who we are and where we come from. Their brilliance wasn't about bending space-time. It was about bending our understanding of life itself. Then there's technology. Nikola Tesla dreamed of wireless power and global communication decades before smartphones and Wi-Fi. Alan Turing cracked the Enigma code, saved millions of lives in World War II, and invented the very concept of computer science. Katherine Johnson calculated the trajectories that sent astronauts to the moon and brought them home. These aren't abstract what-ifs. These are geniuses whose work turned into rockets, computers, satellites, and the devices you're probably using to read this right now. If genius is measured by impact on everyday life, Tesla, Turing, and Johnson stand shoulder to shoulder with Einstein, maybe even ahead. And what about philosophy? Hypatia of Alexandria, in the ancient world, was teaching math, astronomy, and philosophy centuries before modern science had a foothold. Galileo Galilei didn't just point a telescope at the sky. He risked his freedom to say the Earth revolves around the sun. Richard Feynman didn't just win a Nobel Prize for physics. He taught the world how to learn, how to explain, how to be curious. Leonardo da Vinci refused to stay in one lane, asking questions about everything from the motion of blood to the mechanics of flight. Philosophy, teaching, curiosity, these are flavors of genius, just as valid as equations and experiments. They don't always produce instant results, but they expand the way we think. The problem is that we tend to idolize one type of genius, the lone male physicist with messy hair scribbling equations. Einstein became the poster child for genius because he was media-friendly, quotable, and his discoveries were flashy. Time magazine made him the person of the century. But genius isn't one size fits all. Marie Curie spent years inhaling dangerous fumes in a lab to uncover radioactivity. Stephen Hawking fought ALS to become the voice of the cosmos. Ada Lovelace wrote the first computer program in the 1800s, predicting digital technology a century early. Genius doesn't always look like a man at a chalkboard. Sometimes it looks like a woman scribbling notes by candlelight, a mathematician half starving in India, or a physicist trapped in a wheelchair defying the limits of his body. So was Einstein unique? Number? Iconic? Absolutely. But what makes humanity incredible is the diversity of its brilliance. We've had geniuses who painted smiles that still haunt us 500 years later. Geniuses who calculated angles that landed astronauts on the moon. Geniuses who cracked codes that toppled empires. Geniuses who proved that life adapts, evolves, and thrives. Each one played a part in the symphony of human knowledge. Einstein was the violinist who stunned the crowd with a solo, but the orchestra was, and still is, enormous. And here's the fun part. Genius isn't done. It isn't just a historical thing. Right now, somewhere in the world, there's a kid staring at the stars, a teenager scribbling math in a notebook, an artist sketching machines that look impossible, a programmer building something weird in their basement. The next Einstein, the next Curie, the next Turing, they're out there. They may not look like Einstein. They may not even study physics, but they'll leave fingerprints on the future just as deep. Genius keeps coming in new flavors. Maybe that's the real takeaway. Instead of asking who was smarter than Einstein, maybe we should ask how many different ways can a person be brilliant? Because brilliance is versatile. It can be quiet or loud, practical or abstract, ancient or modern. Einstein was iconic, but not unique. And honestly, that's good news, because it means genius isn't locked to one person, one time, or one field. It's scattered everywhere, across history, waiting to be noticed, waiting to be remembered. So the next time you think of genius as messy hair and equations about light speed, remember the other flavors. Remember Darwin staring at finches, Franklin snapping X-ray photos, Noether writing theorems that hold physics together, Tesla dreaming of wireless power, Johnson calculating paths to the moon, Hawking speaking through a voice synthesizer about black holes, Hypatia teaching philosophy in ancient Alexandria, Galileo whispering, "And yet it moves." Each one shows that genius is bigger than Einstein. And that's the real story, because in the end, genius isn't just about bending the laws of physics. It's about bending the way we see the world. And in that sense, Einstein was one of many, part of a long, dazzling line of humans who proved that brilliance comes in many flavors, and it always will.